All right, enjoy the webinar, everyone. Brian, we can't hear you. You're going to have to turn off your webcam.
It's okay. I just bumped my docking station.
Oh, okay.
Is that better now? All right. Sorry about that, guys. Well, good morning or good afternoon, and happy Valentine's Day to those that are on the phone right now. We have a huge amount on the phone to Doug's question. We had over 1,300 people registered, and who knows how many will actually show up. We're well over 500 right now. So my Twitter handle is on the screen right now at Brian Knight, and my email address is on there as well. It's been a while since I've done a webinar for this link, at least, did some of these demos here. So my HR actually sent me a note asking me not to do certain things. Here are some of the things they asked me not to do here. So I just want to make sure Liz will keep me honest here and make sure I don't do these things. But thank you, Liz. All right, a little bit myself. My Twitter handle is at Brian Knight. I'm a SQL Server MVP out of Jacksonville, Florida. I'm the founder of Pragmatic Works. We're based out of here in Jacksonville. We have a number of other offices around the country. I've also authored a number of books around SQL Server, and I blog at a website called pragmaticworks.com. You'll find we have a blog out there today, actually, about some of the new data dictionaries and those kind of things. For those that said they were intermediate, that is perfect. We actually this session is geared at intermediate or advanced level session. We're going to focus on mostly around the data warehouse side. We can demonstrate some good faults of SSIS and some good pros of SSIS by doing some of these topics right here. So we're going to focus on the data warehouse load, the dimension load, the fact table load, how we can do some incremental load patterns, and then lastly, performance tuning pieces around SSIS also. So by focusing on these topics, we can ultimately kind of show you some of the faults that will happen there as well. And I also saw quite a few of you guys had some issues with data warehouses also. I'm going to keep an eye on the questions so far as well. To question from Pratap, we are recording these. All of our webinars are actually recorded. We have about 800 hours of free content on our website under webinars. If you go to our homepage, you'll see a little ribbon up top. It says free training Tuesdays and Thursdays, and you can see all of our older webinars there as well. All right. So to Scott's question about building our first warehouse. So to make sure that we had quite a few people that have not built a warehouse yet or were in the early stages. We have our first piece of this webinar. It's all about kind of the design of the warehouse to make sure everybody's on the same page before we start to load that data warehouse. We are going to have breaks in the middle of this session as well. So about the bottom of every hour, we'll do a quick 5-minute break to make sure everybody can get some water, hit the bio break, and come right back. So first question is, really, why do we do a data warehouse to begin with? And there are really 3 core reasons that really encourage us to do data warehouses. The first one is, I've got data, for example, in my own system. We're building one this week in the conference room, and we've got data in our own system that is not the cleanest in the world. So when I try to ask our CRM how many sales I have by state, I might get 5 answers from that. So I might get, Florida has, spelled 4 different ways or 5 different ways. So one of the things you want to do in our data warehouse is clean the data as it comes in. So if you have USA, US, United States, and U.S.A. We want to make sure that we come out of that with one clean record, one USA record. So that's one of the goals of a data warehouse, is to clean that data as it comes in. Also, archival of data. So for example, in our CRM, which is salesforce.com, we try to keep it pretty lean, because salesforce.com charges us by the amount of gigs we're storing on their platform. So for a lot of activities, we want to kind of get that off the core platform and get it into our warehouse and kind of purge those about every 6 months to a year, or whatever that number is for you. So archival of data, we want to make sure that's really, really lean in our system. And then lastly, the consolidation of data. So we want to get the data from, in my case, I might have, okay, no problem. The consolidation, we might have data that's in Salesforce.com, and we also have data in QuickBooks, and we have data inside of our own training system, like GoToMeeting that we're using right now. And we want to consolidate that into one view. The data warehouse is a great way of doing that. So if it's so great, then why is it a bad word at many organizations? So, oh, looks like the webcam keeps on going off and on here. I'm sorry, guys. I'll just go ahead and, Liz, is that you saying stopping it, or is that myself?
I don't even see it. Well, it just came back up. I would just kill it. It really messes with stuff, Brian.
Yeah, no problem. Let's do
Okay.
that. All right, cool. So the ultimate, why is it a bad word for most companies, for many companies? And it's really around the success rate of the BI projects in general. Back, even 5 years ago, we had a success rate that was just abysmal. So about 50% of data warehousing projects or BI projects failed. And about 2/3 of those BI projects really didn't deliver the ROI that was promised. And there's some really core reasons for that. The main one is really the communication of these two guys right here. The IT guy is a guy who's driving it in many cases. And the business doesn't know why they're driving it. So there's a lot of communication gaps that they have. And ultimately a lack of deliverables because they're waiting for that one big punch, which ultimately creates a lack of trust. Now this is the reason why there's a lack of trust, I think. It's ultimately because most data warehousing projects, especially like the government projects in many cases, ultimately try to navigate the project like this lady is from a data warehouse, from a waterfall approach, where she's trying to get down this waterfall. She plans it all out, and then she ties up, rappels down, and realizes, uh-oh, I made a mistake. So when she makes that mistake, she has to go climb back up, find the new path, tie up again, and then navigate down. So traditional data warehousing projects that are using waterfall approaches don't typically work very well. They're prone to failure in many cases. So you have to really, really watch out for these. They have long planning cycles where it might take you 6 months to just plan how to do the data warehouse. And at that point, your company's already kind of shifted and already veered from the main core goal it had before. It might take you 6 months before you can deliver the first result, and it makes it very, very hard to react. There's a really well-known example here in Florida from a banking company that they spent about 8 months just planning the data warehouse. This is back in 2008. And right in 2008, you can imagine what happened then. The banking industry collapsed, the mortgage industry collapsed. So they had spent almost, gosh, it was millions and millions of dollars on resources, on hardware for their big data warehouse. It was becoming this big, huge enterprise data warehouse. And they had no results because of that. So that's one of the core problems that we have in many, many cases. So the ultimate answer is typically going to be the Agile approach. So the Agile approach is a 1-month iterations, and this is where we try to deliver something to the business every 1 month. We have a complete deliverable, so we'll have the ETL done, we'll have some kind of reporting done of some sort. We'll have hopefully some rough QA done, and it becomes very, very easy to adapt. So as customers change, we can change as well. Okay. Now, with the approach that most of us use, and probably a lot of you guys on the phone also use, is something called Scrum. So Scrum is an agile technique where we basically build a board like this, and we have all of our stuff, all of our items in little sticky notes like you see right here, where nothing is more than 8 hours of work. And there's lots of ways of doing this digitally. Microsoft has something called Planner. There's loads and loads of different tools. Trello, we use Trello here, and VSTS also. And ultimately, we meet around this Scrum board every day, and we say, what did I accomplish yesterday? And what am I going to accomplish until tomorrow? And then what kind of roadblocks do I have? And the goal of the project manager is to remove those roadblocks. But anybody in that room that should be part of that project is in that room. So let's jump into really how do we design this data warehouse. And Scott, this will be for you mostly, and for anybody else in the room that is also in the design stage. So how we design our data warehouse is really broken up into 2 types of tables: dimension tables and fact tables. The dimension tables are ultimately going to answer the where clause, the slicer. What I want to see my sales by country, by product, by resident, whatever that might be. So the where clause is typically going to be the dimension table. It's very, very wide table because we're consolidating a lot of entries into one table. So I might have, for example, products in 3 different areas, or employees in 2 different areas. When it's all done, I've consolidated those, and I have a very, very large, wide table because of that. Now we have this notion of a surrogate key, and this is incredibly important when it comes to dimension loads. Our surrogate key looks like this. So you see right here we have a promotion key, and then we also have this thing called an alternate key. The promotion key is going to be our primary key in our data warehouse, and it's a artificial ID. It's usually an identity column, or it's some kind of artificial identity column it's a number from 1 to 1,000,000 it's automatically seeded for us. And there's some reasons why we'll get into in this. So Scott's asking the question, is a table with over 200 columns too wide? You see that a lot with government entities, especially. You may want to look at the design. It really depends, right? I have to give you the consulting answer here. I have to kind of see the columns to see, is it too granular? Is it, why we have 200 columns? But I have seen columns that are very, very wide like that. It's not unusual, especially with census data. We had I had a census table that was easily like 300 columns one time. I got from the Census Bureau. So it said it's a government entity, so that's very, very common. You'll find a lot of the metadata may be stored that way. And there may be ways of pivoting that metadata, but that could be helpful there. Okay, the surrogate key though. There's a few benefits of this. First of all, let's imagine we are Scott, and we have a very, very wide table, and what represents a unique instance of a resident in our state, for example, might be 4 or 5 columns. It might be their social security address, and I might have their date of birth, for example. That concatenation is a column that I care about. Now, the surrogate key in this case will help us with compound keys because we only have one key on the way out. So we're not having to join all over the place. This is also going to insulate us from our sources. So let's imagine we switched from SAP to Siebel. Ideally, we want to make sure that we limit the impact of that. So surrogate keys can also limit the impact of that. We also want to track historical changes. Now, it's a notion called a type 2 dimension, which we'll get into in a moment, and this is going to allow us to do those historical changes. Now, you want to keep those keys as small as possible, so if you have an employee table with only a few employees in it, then go small if you can. And the reason why is when you're given things like analysis services and you're doing massive fact tables later, you're going to find that it comes in especially helpful. Okay? Now, the last thing here on the dimension table, we'll talk about different types of dimensions in a moment here and how we load those. But when it comes to fact tables, we might have the fact table is our center of our universe. So let's imagine, for example, we are a law enforcement agency, and I've got maybe a customer right here. All right, for a law enforcement agency, we'll call that a perp. And then we've got maybe the types of reasons I'm pulling him over. So incident type. There we go. And then in our fact table in blue here is in the center of our world. So we're kind of keeping it simple here and only having only two dimension tables. But the fact table is the center of our world, and it has the foreign keys to these two tables right here, and then so on and so on and so on. That's what I call this a star schema, because it looks like it's a table that kind of fans out from there. So you would have things like the surrogate keys in here, perp SK, the incident SK, and then we'd have maybe the fine they paid and time served or whatever. So these two numbers that you're seeing right here below this line are going to be our measures, are our numerical values that we want to slice, that we want to see in our sliced report. And the top two numbers are what are we slicing on. So once you slap this inside of any kind of BI tool like Cognos or Analysis Services or even Power BI in some cases, it will go ahead and help you, build these reports very, very quickly because of this. So it's kind of refined for this. Okay, so that's where our surrogate keys kind of come into play in the fact table. They become the foreign keys. Now there's really two types of dimensions, three types we'll refer to here that we'll refer to when it comes to SSIS. The first type is the type 1 dimension. The type 1 dimension allows us, is really about how we track changes here. And this is a column by column decision you're going to make. So for example, if you have, if I want to update this customer on the right's address information to go from Blackshire Street to Main Street, we'll call this column a type 1 column, which means we are not keeping track of history. All we do is just say, all right, the update comes in, and the customer never lived at Blackshire Street. They've always lived on Main Street from this point forward. Again, this is a column-by-column decision. So for example, last name, you might say, oh, well, I care about history there. But first name, I don't care about history there. So you can get very, very granular on that. A type 2 column is also called a historical attribute, not a changing attribute. It's a little typo there, sorry. And a type 2 column is where we keep track of changes. So in this case, it might be a big deal. For example, the address line 1, Main Street, I don't really care that somebody changes that. I'm going to go ahead and just overlay that. However, if somebody changes the zip code, that is a big deal because now you live a sizable distance from my store. So when I pass this record in, notice I have my surrogate key right here of 10, and notice I have a start date, end date column here. Right now, because this end date is null, this record right here is my active record. And when I pass this data in, I'm going to expire this first record, create a new customer, Miles Harris again, at the new address, new zip code, who just started and just ended. So yes, this has an active record now. Now there's two ways we can do that active record. We can have an active flag, or we can have a start date, end date, like you see right here. There's a number of options we have here. Some people prefer to have the active flag true, false. Some people prefer to have start date, end date. Most people I see that do an active flag also do the start date, end dates, because the start date, end date is very interesting metadata to keep. So there's nothing against having all three columns, start date, end date, active flag, and I'll show you ways of doing that once we get into this. The other thing that I get questions around lots here is that end date of null. Some people prefer to not have a end date of null, but to have an end date like 12/31/999, for example, like a date arbitrarily in the future, like 2099 or 999 or something like that in the future. That's absolutely possible, and I'm going to show you in SSIS how we'll accomplish that also. So a question here about when do we use snowflaking inside of a data warehouse? That's a good question. So let's imagine, for example, kind of draw my example we had before. There's my fact table, and I've got a product dimension in my case here. So I'm going to go from here to a product dimension. All right. There we go. It's called prod. Now, in my product dimension, though, I've got things like, I've got columns like, let me shrink this down just a bit so we can all see this. Of course, we have a product SK. We have a product AK. The product AK is the primary key from our source system. That is our alternate key, or it's also the primary key from Siebel, from SAP, from your inventory system, whatever your primary key from that system is, and a surrogate key is just an artificial number that we created in our warehouse. All right, so below that, though, of course, we have the product name. We'll have we might have a category of the product. We might have a size. We might have a subcategory. We might have you know, the category name and all that as well, a description and all that. So let's imagine we have millions and millions of products, and I want to change the name of the subcategory from apparel to clothing, for example. If I do that, I'm having to go and update potentially millions of products and really cause a big ETL challenge in many cases. And that's where snowflaking makes a lot of sense. Let's imagine these two columns that you're seeing right here, this category and subcategory right here. If I have, let's say, more than 5 or 6 columns that represent that group of columns, it might make sense to separate it out into its own category dimension right here. And you have basically a one-to-many going this way. So it always fans out. You start in the most granular that's attached to your fact table, and you fan out to product and category, then subcategory, then subcategory, then category, and so on. But if I have a sizable amount of columns right here, for example, then it makes sense to go ahead and separate that out. So I'm only updating that one record, changing it from apparel to clothing, versus have to go and update all million records in my product dimension. So hopefully I answered your question. It's one of the many answers around that. There's a lot of subjectivity around that also that may or may not, that there's a whole bunch of gray area there. So it's not always a 100% best answer there. But to me, it all depends on the number of columns and depends on the number of rows I have in a table for that granularity. Okay, the last type of dimension we'll cover here, there's actually quite a few more types of dimension, but the last one that really shows in SSIS is a type 0 attribute. The type 0 attribute is where I'm changing somebody's value, like for example, I'm changing somebody's social security address perhaps, or in this case, I'm a healthcare company and I'm changing the gender, for example, or the social security address. In this instance, now I'm saying that this is going to cause an exception because I don't expect this kind of update. So when I send this in, I have two options in SSIS. One option could be to fail this, and one option could be to go ahead and ignore the update. What most people do is they go ahead and they ignore the update and they write that row somewhere else into an exception table, and that exception table can be addressed at a later time. So if somebody breaks the rules and sends in a social security address change, that's a big, big change. I want to know about that, and maybe my source data is bad, maybe my destination data is bad, but I want to at least manually make that change versus and do some gut checks first. Okay, that's called a fixed attribute or a type 0 attribute. So again, we have three types. Type 1 is called a changing attribute in SIS. It's for that where I don't care about history. If I care about history, it's called a historical attribute, and it's called a type 2 change. And the last one is where I don't allow change at all. It's called a type 0 or a fixed attribute. Now those are all terms, the ones in parentheses are the SIS way of calling it, and type 0 is more the standard modeling term. The last piece here is called an inferred number. You see this a lot in healthcare especially. This is called also in common terms called a late arriving fact. So let's imagine in this case, and this is also supported in SIS, that I've got a fact table load, and I'm going to try to look up the product dimension, say, all right, I have this product coming in, BKT800. I don't have that product over here. It doesn't exist. So I have two choices right now. One of my options could be to flag that sale coming in to an unknown record. And this is the most common you'll see. You'll see people flag it to it's called a -1 record, just a stub record out there. So that's one option. We can basically flag that sale. We don't want to throw the sale away, but we want to go ahead and attribute that sale to a product called unknown. Now this happens a lot when systems are out of sync. It's like, let's imagine you're in the insurance industry and you have a agent who made a sale who just joined our agency. But he made a sale, but he's not through HR all the way yet. So he hasn't, my master record for the agent is my HR system, but he's not fully through that system yet. So in this case, we can have two options. We can flag that to an unknown agent like we're doing right now, or we can create a stub record with what we actually know about. So we know this product is a BKT800. That's its alternate key. It's its primary key from our source system. We know that product's name is a Tour Elite, and that's all we know about this product. So we'll go ahead and put unknowns all the way down. Now what's going to happen, you'll notice the inferred number flag down here is set to true, right there. And because of that, what SSIS is going to do is whenever that dimensional record comes in, whenever that bike finally comes in or that agent finally comes in, it will go ahead and change all these unknowns you see right here to their actual values and then change that true right there to false once it makes that change. So we'll see that actually change and it's all done. So you can imagine there's a lot of rules around this, right? It's a crazy amount of rules that creates a huge ordeal if you're loading these. So imagine doing this in T-SQL. It's not fun. In the past, I had to do this in T-SQL, and it was every dimension I would basically guess it would take about a day to do in many cases. Depends on how hard it was, but once you get to type 2s and type 1s, it became really, really hard, and that's before we had things like the merge syntax that we have now in SSI and in T-SQL. So let's jump into how we do this in SSIS at last. Okay, so in SSIS, there's a number of ways of doing this. We're going to cover the easy way and get a little bit harder, but a little bit better performance as we get deeper. So I'm going to show you a good, bad, and a good way, a better way, and hopefully the best way. So the good way of doing it that works about 90% of the time is something called the SCD, the Slowly Changing Dimension Wizard. Now, this is a transform you're going to find in SSIS, and it essentially is a code gen tool. It's going to produce all this code for you. The reason I say this works about 90% of the time is it will handle about 90% of the use cases that you might have. So it will help, well, I say 80%, 90%, it's relative here. It is very, very fast from a design time perspective. So we'll go ahead and we can pump out these dimensions, super, super fast. And it is customizable slightly, but it has some faults, and we'll cover those faults as we get into this. So let's cover our first demo of the day. So what I have here is I have a club table. This is my OLTP environment, my transactional environment. And you'll see I have a club name and I have the club ID. Now this club ID is my alternate key. That's the primary key for my source system. Now I'm trying to get this into my data warehouse right here. Now this is considered a college here. Let me go ahead and turn off Skype. I apologize. There we go. All right. So my data warehouse here, oh, go away. My data warehouse here has this column called, or this table called dim club. Apologize for the underscores here. I hate underscores myself. And I have, again, my surrogate key. I have an alternate key, so that club ID you saw before will map to club AK down here. And then I've got a club column right here. So we're going to basically load that and see how we can make this work. All right, cool. So let's go ahead and, so I have a few people that are arguing about underscores. I understand. I like camel casing. It's a religious battle, isn't it, Raghav? It's, some people like them, some people don't. All right, so it's a pet peeve of mine, I guess, in my case. So let's go ahead and let's load that table. So I'm going to get the data from this club table into dim club table down here. I got a whole bunch of people saying they like underscores. I got you guys. I'm sorry. I shouldn't have even gone there. It's my pet peeve, not some people's. All right. So let's start from a brand new entry here. All I have is an OLADB source. I have my two connections down here. This part is not going to be at an intermediate level. This is going to be, just kind of starting us off here. And what you'll see here is I have my OLTP on the left, my data warehouse on the right, and I have a simple data flow that I've dragged over. And the data flow, I dragged over an OLADB source over. Okay? In my OLADB source, I want to get some data. Now, the one rule around SSIS is sure is easy to go ahead and pick club here, isn't it? As my source. Whatever you do in SSIS, this is not a whole lot of always rules, but from a performance side, never, ever, ever pick this option right here. And there's a whole bunch of reasons around that. One is around metadata, we'll cover in a second, but the main reason is performance reason. So I started a battle now in chat to underscores and no underscores. That looks like sorry guys. So we need a poll question on underscores, don't we? All right, let's create a poll question for underscores or no underscores. I'm curious later for that. All right, so the what we have here is I want to go ahead and change this to T-SQL instead, and there's a reason why. So let's imagine, for example, I'm just going to keep it simple here. Select star from dim. Oh, let's show you the whole way first here. Let's pick a column. All right, so let's imagine, for example, I go into financial aid of some sort here, or standing, whatever. And oh, that's too simple of a table. Let me find something a little more interesting here. Participation. Okay, so let's imagine that if I have this, and I want to go ahead and uncheck some of these columns, I don't really care about these first four columns. So by doing this, what I've had to do is I've ultimately said I don't want to send those in memory, which is a great idea. I don't care about the three columns. By unchecking those, they will not be sent into memory. The challenge here is if I do this, it also has some issues though. So it's still going to run a select star against this core table. What's participation here? Runs a select star against participation, brings the entire table down, and then removes those tables from RAM as a client-side filter. So that's one of the core issues with this. Is if you do it this way, it's doing a client-side filter, and it's still going to bring all those tables over the network. So be very, very careful when it comes to this option right here. Instead, let's do a SQL option only. and that makes it much, much easier. I'm just going to go ahead and get all my columns from the club table. A little trick I'm going to do is I'm going to say select star at first. I'll hit build query and then hit OK, and it'll blow up select star into the right columns here at least. Would not a big deal with 2 columns, but if I had a whole bunch of columns, it would go ahead and add those there. So if I wanted to now, I also want to keep this a little cleaner for me to understand what I'm doing later. So I'm going to go ahead and alias this column. This is my own personal best practice. I'm going to go ahead and alias this column as club_AK, because that is a name on the destination. So one of the things I personally like to do in a data warehouse load is to alias the columns as their destination name. The reason why is a lot of these wizards are going to see the names match, and they'll go ahead and line things up for me automatically, because you're going to open and close that wizard all the time, and you don't want to have to map those over and over and over again, as Bob is pointing out right now. Okay, so let's go ahead and hit OK. So this is our club table. I'll go ahead and I'll be nice and just do SRC clubs, so we have the naming convention just for this first component here. All right, so with that now done, let's go ahead and drag over our slowly changing dimension transform. I'm going to wire it up into this, and let's double click on it to configure it. All right, first question it's going to ask, this is native to SSIS, by the way, and it's not third-party component here, and we'll cover the pros and cons of it a little bit later. Now, if I pick my data warehouse as my dimension I'm trying to load, now I have a little DPI issue as you're seeing right here. This is a resolution issue, but just trust me, that says dim club. It's a little hard to see, but it looks like dim club to me at least. Okay. Normally, if it's the higher resolution monitors where they didn't really plan when they have a few bugs on it with SIS, where it's a little tough to see. Okay, so a few questions we have out there already, just for those that are already going there that are not underscore related. We are going to I'm going to post these slides onto our blog. On the Pragmatic Works blog later today, so you'll find those there. There are some comments in there as well that you can kind of use for hints later, or if you want to kind of brief your team or those kind of things. So that's one of the questions I'm seeing over and over again, but we will happen to have that. Okay, so we have our dim club table mapped. So again, so far all we've done is I have my club table coming in, and I want to send that to my dimension table now. So I've mapped dim club here, and these are my columns that it's finding in my data flow right here. These are my columns right here from my club table, not my dim club table. On the middle here is my data warehouse columns. So this is my OLTP. This is my data warehouse based on the mapping I have right here. This is why I alias the column though, because now it's rather than have club ID, it has club AK, it maps up beautifully, and that is my primary key across both systems. So if I hit this drop-down box and select business key, I'm basically saying this is my alternate key, this is my business key, this is whatever the column that maps across those two systems. Okay? Now club is just a regular column. These other columns you're seeing here will be used later. Those are going to be my columns I use for type 2 dimensions a little bit later. So let's go ahead and hit next. Now we're going to define, hey, this one column I had left, and I would have a row here for every column I had left. In my case, only one column left. What is that? Is it a type 0? Is it a type 1? Or is it type 2? And you'll see right here on the left here, changing attributes are type 1, historical attributes are type 0, or type 2, excuse me. So let's keep it as a changing attribute for the time being. And I'm going to run this wizard through twice here so you can kind of see how it looks different from a type 1 side and a type 2 side. Let's hit next. And then the next question is, all right, well, this is kind of a goofy question, I think. And this is probably the longest property you'll ever find inside of a Microsoft product. The property, the checkbox is, change all matching records, including outdated records, when changes are detected in a changing attribute. If that doesn't drive you a little nutty, I'm not sure what will. So here's what this means, this property means. And I don't know how much alcohol was being consumed when they came up with that property name, but it had to be a lot. It had to be a Friday night, a debate, I don't know, who knows. So let's imagine, for example, we have a a mixture of type 1 and type 2 columns. So let's imagine we've got a customer ID. All right, I'll call it cust ID, or SK. Cust ID. I've got first name. I got a last name in there also. And maybe I've got a city. All right. And I'll call this an active flag over here also. Okay, so I have customer ID 1 right here, whose ID is ABC, and her first name is Jen Jones, who lives in New York City. Now, she is currently at active record, but something happens. She gets married. All right, so she's no longer the active record. Customer 150 is now the active record. It's still ABC. She's now known as Jen Knight, which is type 1. So it's type 2, excuse me. All right, so she's now the active record. All right, so let's imagine though that the city is a type 2 column. So in the city column, if somebody were to change that, how do you want that to behave? Well, you would expect, first of all, that we would change this to the new city, because it's type 2, to Jacksonville, for example. Oh, I misspelled that. There we go. Now, with that checkbox unchecked that you previously saw, this is the behavior you would see. I would change Jen's city to Jacksonville for the active record. However, if we were to check that box, it would basically go back and it would say, oh, she's always lived in Jacksonville. So it would make her live in Jacksonville here as well. So the question really comes in is when a type 1 update happens, do you want to expire or do you want to change all the expired records also? So that is one of the options you have there. So I have almost never seen a reason to check that box. So it's up to you, but it's a very, very rare reason that I found to do that. The last one is, do you have inferred numbers? Keep in mind, inferred numbers are the late arriving facts that we had before. This is, hey, I'm missing an employee. I have a sale for an employee who doesn't exist. Do we have that? No. So I'll go ahead and uncheck that. I'll hit next and then finish. Now what's going to happen is it produced the code you're seeing below the SCD transform, slowly changing dimension transform. So it produced this code, and it has some pros and cons to it. So if I were to just go ahead and run this as is, first of all, let me make some changes here. Let's get a little crazy here on Dim Club. Let me go over to here, and let me go to Club, excuse me. All right, let's find something to make a change on real quick to make it a little bit interesting here. Okay, so let's go ahead and let's change the Glee Club to the Glee Fan Club, the old Fox show that used to happen, the old sitcom that was out there. So that is record 11 here. So let's go back over to our queries, and let's look at a new query against my dimension. So select star from dim club, and let's look at where club AK is equal to, I think it was 11. And I'm in the wrong database. Go to my data warehouse. There we go. So right now we have a mixture here, type 2 and type 1. That's fine. But we have this Glee Club that we have here. That's our active record. Oh, we have both. They're both active. Uh-oh. So let's do a quick cleanup here. Delete from dim club where in date is not null. Oh, I got some foreign keys in there. All right, whatever. All right, so if I were to run this, we'd hope to see one of those that turned to fan club. So let's go ahead and run this. What we're going to see is our new records go to the left, and our updates go to the right. So we'll have one row that went to the right. There's only one update, and we'll see that update now here. The Glee Flame Club actually got updated now, and because they're both active. So what we're seeing here is new data goes this way, old data goes this way. And so that's what it's doing. It's basically handling all that for us. Now there are actually more than just the 2 lines that you're seeing right here. There are actually more lines as well. So if I wanted to, let me just send something to this dead end right here for the time being. Now this will actually show us what are the lines we have available to us. So we also have, unchanged attributes. Now this is kind of handy to know how many duplicate records has the source system sent us today. How many records that are already in our data warehouse did the source system send us today? We can count those and log that into a table somewhere. Okay, so let's make this a little more interesting. Now, there's some other things, some performance things we'll cover a little bit later. So you're seeing here, first of all, that the insert, what's happening here? So it's inserting all my new data using this to a classic OLEDB destination here. Now, the problem that we have here is the wizard produces some code that's not so optimal. So for example, it did tabular view. Well, tabular view is essentially going to insert row by row by row into our DEM Club table. So instead of doing that, I want to do this as a batch-based. So I'm going to change this to a fast load, and it's going to batch the data in versus doing a row by row kind of insert. Okay, so we're going to see a bulk insert now into DEM Club. We'll come back to these settings right here a little bit later when we get the performance tuning and stuff. So when I hit OK, that will speed up our component quite a bit. On the right side, we're seeing an OLEDB command transform. So if I open up this is now the editor we're seeing right now is called the Advanced Editor for OLEDB Command. Now this is the Advanced Editor is because whoever wrote this component doesn't really want you to use it because they did not build you a UI. If there's no UI inside of SSIS, it shows us this component right here, this Advanced Editor we're seeing right here. So we want to hopefully find some interesting things around this. So as we're seeing here, it's basically doing an update, a row by row update. So this OLEDB command transform is essentially the patron saint to all things that are sucky. There's a few reasons why. The OLEDB command transform essentially will do a row by row update. So it does a row by row cursor essentially against our system. But not only that, but it is going to open and close the connection for every row going through it. So it's going to open and close, it's going to open a connection, run the update, close the connection. Open a connection, run the update, close the connection. And if I had that 5,000 times, we're going to be pounding the heck out of our table. So the one way of fixing that is there's one little property that we can set to tune this a lot better. So that setting is we can go ahead and select this component right here, this destination right here, this data warehouse, and the property you can set, which is an advanced property over here, is retain same connection. If we were to change that to true, ultimately what's going to happen, this OLEDB command transform is going to still suck, but at least it will suck a little bit less. It's going to keep the connection open during the whole running of the package. Now there's a pro and con. As a few guys are pointing out, every pro has a con, right? The pro of this, of setting that setting, is it keeps the same connection open, and it's going to speed it up quite a bit. The con is it keeps the same connection open. So if this package runs for 3 hours, and this is only a 20-minute process right here of that 3 hours, it's keeping the connection open and can potentially cause some problems. That's why they said that property defaults by default. Let's go into this guy, the insert destination. I had a few people here, like Bob, for example, made some comments. I'm going to come back to these in a second, but just note, I got this table lock property on. It will still, it can cause some havoc in there if I have a lot of rows going into that also. So the pro is it bulk inserts the data in. The con is it's going to escalate my locks quite a bit in this case. So it's going to do it much faster, but it will, and it's all or nothing as well, right? So if a few rows fail, I can have some issues there as well. It's basically a bulk insert command. So just like bulk insert command, it has the same flaws of the bulk insert command. So every pro has a con in SSIS, just like the rest of technology, right? All right, so let's go ahead and I've tuned that now by changing that one property. Again, that property is the destination right here. One click on it, and you'll see retain same connection. You'll set that to true. Now you only want to do that when you have a whole bunch of OLEDB command transforms in your package. Okay, that's it, and you're basically putting lipstick on a pig. It's the prettiest pig out there, but it's still a pig. So let's go ahead and change this guy to a type 2 dimension instead, and let's kind of watch what happens to it. So let's go ahead and double click on it. The only change I'm going to make, I'm going to go ahead and hit the next button. Only change I'm going to make is I'm going to change this from a changing attribute into a historical attribute. So I now care if I change the club name, do I get more people because of that? That's the whole reason you keep track of history, right? So is this person having more sick time now that he's married now? Or he's having less sick time, for example. So you might have two versions of that employee, right? The unmarried version of the employee and the married version of the employee or customer. And how is that customer's or employee's buying patterns different now versus after he got married or she got married? Okay, so kind of some interesting stuff we can do with analytics around that. So when I hit next, it's going to insert a brand new screen inside this. The new screen, all right, so the new screen is going to show us, it's going to ask, all right, what is how do you want to expire the record? Do you have, for example, an end date like this, start date, end date? Or do you have an active flag like you're seeing here in the red? All right, so we have a little bit of both in our case. I'm going to start just with the start date, end date, because you can only do one in this wizard at a time, and then we'll have to customize everything else. So let's do the start date, end date, because that's the hardest one to do. So I'll select my start date column, my end date column. So it's reading these two column names from my dimension table you see right here. Okay, it didn't make those up. Now, what date do I want to set these two, this start date, end date to? Well, I'm going to set it to the container start time. That's the most granular I have. There's a few things you want to avoid here. It's showing us all the variables that are date times. So the variable you care about here is the start time of the package or the container start time. Make sure you never select the creation date of the package. Otherwise, it's going to expire the record to whenever you created this package, not to when the package ran. The container start time is when this task began. So it's the most granular you have. There's other ways we can set this also. We'll show later. Let's go ahead and hit start, or next, excuse me. I'm going to buzz through the rest of the wizard. It's the exact same wizard. Now it creates some code now that's slightly different, but it's ultimately a little different angle here. So what we have now, you have our type 2 updates going down the left side. Our new records go down the right side. So what we're seeing here is, in this case, if I want to expire a type 2 record, an expiry is really an update plus an insert, right? I have to go ahead and set this record that you're seeing right here, this Glee Club right here, to 0, and then I want to create the new record after that. So when I do an update, I'm going to see an update here, right there, and then an expiry, or then a insert down here. So here's what it looks like. First of all, the derived column right here is going to say, all right, well, what do you want to go ahead and expire? Well, this is my container start time you just saw. So you could customize this to be whatever you want here. The next piece is it's going to go ahead and expire the record. So here's my update right here. I'm seeing, okay, so let me go ahead and update this again. Let me open this up here. So we're seeing it saying, okay, so it says update set the end date equal to question mark. That question mark's going to be passed in. And then I'm going to set the active flag, since I'm expiring this, to 0. This is how you kind of customize it a little bit more here. All right, I'll hit OK. So I've now expired the record. That's going to it's going to merge back in with the new records, the new data. And then now I'm going to set the start date. Here's my start date right here, equal to the start time of this package, or this container. And again, I'll do active flag here. And in this case, it can be true now. So now I'm turning on the new record coming into it. All right, then I go ahead and insert the data right here. Now look I'll come back to that in a second here. So you'll see, okay, start date, end date looks good. Let me go ahead and drag active flag over so we can map it. And then we're done. So I now have both the start date, end date, and the active flag. Keep in mind the end date will be null right now because I'm turning this record on in this case. Now look what also happened. It went ahead and turned it back to table or view. So essentially every time you go through the wizard, it is going to drop all the code you did and then recreate it all over again. So I'm going to have to go ahead and go to fast load. So that's one of the biggest cons of this wizard is that it's ultimately going to drop and recreate the code. Big con there. Huge con. All right, let's go ahead and run this again. We'll see almost nothing happening right now. All right, it's going to go ahead and run that. There we go. All right, again, 114 rows came in. Nothing came out. Let's go ahead and make a change real quick. Let's go back up to our club table here, and let's change this back to, let's make this the Brian fan club versus a Glee fan club. Let's run that again. So now we should see, hopefully, a record go through this left side and then out the right side. Let's see what happens. All right, there we go. So there's our one record that was expired and our one record that was inserted. So let's go back and see what happens here now. There we go. So it's a little bit confusing here because I have a bug in my data right here. But let's assume these two records are the only active records that we have here. Let's ignore that guy right there. All right. So we have the Glee fan club that was expired and the new Brian fan club that was created. That is now the active record. It's the active record because you can see it has an active flag of 1 and it has an end date of null. So a question around our version of SQL Server. I'm running SSIS 2016. However, the same UI applies to really 2005 and greater. They have not altered the UI in any sizable fashion for this component in SSIS 2015. So it looks pretty lame, right, as far as the UI goes. The same flaws you had since 2005 apply here as well. That's your question, Raghav. A few other questions we have here as a system version. Okay, so we have how did the SK get assigned? That's from the question from Scott. This SK is actually an identity column. So it's getting auto-assigned by my table here inside of that. So there's other options we have as well. We have a product called Task Factory, which has a surrogate transform. And that's one of the free components of that that you can actually assign them in SSIS if you want also. But really, the identity column is probably the best way to assign those, Scott. Question here about a history table. So Robert, what if you wanted to insert into a dim history table? That's essentially, I see the point of dim history tables, but that is essentially what we have here is where we essentially have the before and after image of this. Some people prefer to have that into a separate table also showing this. If that's the case, you can branch off right here in historical attribute. You can branch off and do an insert more using some conditional splits into that left side also. Okay, why has Microsoft not updated this tool since then? So, good question. I think, well, you know, we build a third-party component called Task Factory, and we have a refined version of this whole logic. It's something called a dimension merge that we built that makes us about 900 times faster, Phil. And the reason why Microsoft hasn't this dimension merge right here that we have is we have some dirty pictures on some of the developers at Microsoft, and we have some incriminating evidence, and they won't improve it because of that. It's a bad joke. Anyways, I don't know. Unfortunately, they said we have a solution here for you guys. There's some third-party solutions out there, and because of that, it is what it is. I think we're almost at break time. Devin, are you there? Okay. Okay. We are at break time now, so let's go ahead and do a quick 5-minute stretch break. And let me go ahead and pop in real quickly here. A 5-minute break, and we'll come back and we'll finish up this example and a few others. I'll put 5 minutes on the clock now. Go stretch your legs, get some water, and I'll see you in 5. Thanks a lot, guys. Hey, Devin, are you there?
I am. Can you hear me now?
I can.
That's
Are you
good.
sharing? Let's see.
Let me present real quick.
There you go.
All right, good deal. So as we come back from break here, Brian's gotten a good start on loading a data warehouse, and I have some good news. So I saw some people in the chat talking about, should I stick around here if I'm pretty new to SSIS and kind of wondering, is this a good fit for them? So let me make sure I'm showing the right screen here. Here we go. What I'd like to show you guys just briefly here is a little bit about our on-demand training. We're going to jump right back into the webinar that Brian's doing, so don't worry, I'm not going to talk for too long here. Our on-demand training is actually something that we're going to be sending out to everyone in the webinar today, a special offer on. And it's our subscription model that we have for training. So you're attending some free training right now that we do on a weekly basis. Usually it's not 3 hours like today, but we also have paid training, which is much more in depth. The topics that Brian's covering today, we also go much more in depth, and even we have a full class that we're going to be designing around loading a data warehouse, and we're almost close to wrapping up a course on designing a data warehouse and really doing more of the database design component. So if you're interested in some of that, I encourage you to take a look. If you go to our website at pragmaticworks.com, you'll see on the homepage where you can get a trial to our on-demand training. And it's very, very nice. They're lengthy courses. You can see as you go through any one of the courses, they range from 3 to 4 hours to some of the courses actually are up to about 14 hours. So we have a variety of different links just depending on the topic. And you'll likely see if you work with Microsoft SQL Server and BI, there's a lot of topics in here that really fit into what you're doing. So I encourage you to take a look at the trial. It's a fully functioning trial that allows you to go through everything that we do in the courses. And you can actually take a look, and they're all video-based training along with quiz assessments that happen after each one of the modules. So I encourage you to take a look at that. If you have any questions, you can also email training@pragmaticworks.com. I'd be happy to answer any of those. And I'll leave it at that. I want to make sure you guys have enough time for new material here.
Yeah, and this is actually part of our Masters of SSIS class that we're teaching right now. So
exactly. Yep, absolutely. All right, I'll pass it back over, Brian.
All right, cool. Let me go ahead and take over. Make me presenter. There we go. Make myself the presenter. All right. Well, thank you. Welcome back, guys. Hopefully you got a good bio break there. And then let's get back into it. So we left off. We were loading our dimension table, and we have a boatload of questions. I'll go ahead, and a whole bunch of people that are already actually subscribers, Devin looks like also. So that's good. So the dimension table we have so far, this data warehouse load we have, has some pros and cons to it as well. So the pros are, and I see a few of them in the chat window right now also, the pros are, it's easy, right? We were able to pump this out in, 30 seconds, but next, and it finished its job. The cons are, if I went next, it's going to wipe away all my code and then re-add it again. That's one of the big cons. The other con is when you look at this, and first of all, this component right here, it's doing a row-by-row update. We have this guy right here is putting rows into buckets, and it is a very, very slow process because of that. So it puts new rows into one bucket, type 2 updates into one bucket, type 1 updates into one bucket, and so on and so on and so on. So it creates it's a very slow process because of that. So this scale has some scalability issues. So when you look at the overall the weakness of it, Debbie, you're still on mute. It has some maintenance issues, and it has some speed and scalability issues. So this will scale to about, now this all depends on the hardware you're running it on and all that, but generally no more than about 50,000 rows that are going through this. You'll see it really start to struggle. You'll see it like take potentially hours to run versus seconds, like you saw mine run. And you have to send every single row into this as well. So it has a lot of issues with it. But it might solve about 80% of your problems by having this. And 80% will be a pretty big savings on yours. So you can pump out a dozen dimensions a day that are the easy ones. But in that big product SKU dimension, every company here that's on the phone right now has that big old dimension, that our big old table that you all groan about when you think about what we have coming up when you're designing some work. So those ones need an alternative design. And there's a number of ways of doing that. So I'll show you some ways of kind of building your own. You can, of course, do some T-SQL and use, as some of my friends on the chat window are saying right now, you can, of course, do that as well. Use a store procedure, or instead of SCD, use like the merge syntax for doing that. But it definitely, it's nice about this is kind of self-documents. So let's kind of go into this. All right, so one of the alternative designs is using things like a lookup transform to find out is the row there or not. Now this is only for a type 1 update here, but it works fairly well. We're basically talking about the upsert pattern. So the upsert pattern is looking at our data. So rows come in and we say, all right, do I have this row or do I not have this row? And we decide, if I have the row, it must be an update, or it might be an update. If I don't have the row, it must be an insert. So essentially we'll have a series of lookup transforms and a conditional split to kind of split those rows. So let's kind of look at what that model looks like. I'm going to open up this upsert item you're seeing right here. And I'm not going to build this from scratch. I'm just going to kind of open this up and kind of walk through it instead. So I have a whole bunch of transactions. Let's go ahead and you'll see I'm pulling from this production transaction history table here. I'm just going to give me all the rows from that table. Let me go ahead and make some drastic changes to that table first of all. So I'm going to delete, helps find me in the right database here. There we go. I'm going to delete about 81,000 records, and I'm going to update about 800 records here in this case. Okay, so we made some pretty sizable changes here just to kind of make things move around a little bit here. So I had to get all those rows synced back down here. And you're seeing my new rows are going left, my updates are going right, and we'll come back to that in a second here. So I'm sending my new data, my source table is going into my lookup transform. And you can, of course, use merge, you can use lookup. It's essentially doing the same thing in this case. If I go to my connection, this is my destination table in this case. It's called CDC Transaction History. That's my destination table. And it's also in the higher ed database. It's not really a full-blown data warehouse. So this is going to apply to really if you're just trying to synchronize and do upserts. So whether it's type 1 dimension or whether it's just an good old-fashioned transaction table. It doesn't really matter. The upsert pattern applies to a lot of different things. I'll go to columns, and we'll see I'm mapping based on my primary key. So the left side is my source system. The right side is my target table. And notice I'm aliasing all the columns I'm getting from the right table as target underscore. So I can see, well, here's what the value wants to look like. Here's what the value wants to look like over here. Here's what the value looks like right now. So if it says target underscore, I know it's the destination. Now, one thing you'll notice if I go back a screen here, it says that if I can't find a match, it's going to ignore the failure right here. This essentially does a left outer join, or essentially it's going to say if I can't find a match, set it to blank, set it to null. So if I try to look up the transaction ID and I can't find it on the right side, it will essentially null it out all the way down. So all of my target underscore columns will be blank all the way down. And that's how I can tell if the record is already, if the record is not in that target system. Okay, so in this case, I'll look over here, and this is my conditional split. So there should be 3 conditions here. Either I've got the record, either it's a new record, so if that target is null, like I just talked about, then it must be a new row. If this column is not equal to this column, or that's an or right there. This column is not equal to this column, or, and a hand cramp later. If all those columns are not equal, then it must be a update. Otherwise, it's a duplicate record. That's my else condition right here. Okay. So there we go. Let's go ahead and hit OK. Now, in this case, by the way, it's this lookup transform I had here. This transaction ID would represent my surrogate key in this example. All right. So my new data goes this way. Okay, classic little fast load turned on, everything looks better there. And my OLED command goes this way for my updates. So I made a whole bunch of updates. Let's go ahead and run these, and let's see what happens. All right, let's turn on my task manager too so we can kind of watch the performance of my portable laptop here. All right, there we go. We're eating up a lot of CPU right now, about 80% of my CPU. About 20% of it is being used consumed by SQL Server. And look what's happening. I have about 100,000 records total to update, but it is just spinning and spinning and spinning right now. Nothing is happening. Now, I want to stop it here in a second, but just trust me, this takes a long time to run. And there's some reasons why. Now, first of all, you have this this notion right here of a table lock happening. So let's turn that off first of all. I just want to kind of demonstrate that how big an issue that could be. So let's go ahead and turn off table lock. Let me make my updates again. There we go. All right. Let's spin this bad boy again. Let's see how we do this time. There we go. We're still spinning though, but it's not a locking issue. So the challenge we're having is this OLEDB command transform, again, is the patron saint of all things that is sucky. It was written by this a terrible idea, maybe a bar bet or something. It is ultimately doing a row-by-row update. At the same time, you're trying to pound the table. So it did finish, but it took about, what, 27 seconds or so to finish once I turned off the table lock. So there's got to be a better way. Now, the ultimate rule I want you to get out of this is you should avoid using this OLEDB command transform if at all possible, because it is a very, very slow process to do. So the way around that, if I were to go to my control flow again, I have this whole other concept here. Let me open this up real quick. It's the exact same code you just saw, but this time the only difference is there's no OLEDB command transform. This time the OLEDB command transform has been replaced with a OLEDB destination. So I'm inserting this time into a staging table in this case. And then once I inserted the staging table, I've landed my records, and then I can do a big set-based update with good old-fashioned T-SQL. So this should look familiar for most of you guys, just good old-fashioned T-SQL, just doing an update to that same table, and I'm saying we'll go ahead and truncate the stage after I'm all done. So it's a 1, 2, 3, it's a two-step approach. So the lesson learned here is you want to get the updates out of the control flow and get them out of the data flow and into the control flow. So by doing that, it's going to speed it up immensely. So we were at 27, 28 seconds before. Let's see what happens this time. All right, again, 100,000 this time, new records, 800 updates. Let's run the whole container here. All right, we were at 27 before. I'm guessing we'll be a little faster now, we hope. So take a wild stab. Go ahead and write down on a little sticky note or something how fast you think it's going to be, how much faster moving the OLED command transform off is going to make this. So just kind of make a mental guess to yourself, a little side bet here. All right, here we go. Hopefully your side bets are in. Let's go ahead and run this container. I have a private betting problem, I guess. There we go. It's doing my updates. Oh, already done. So my updates have already occurred, and my set-based update occurred, and all of that occurred in 2.9 seconds. So much faster process to do a big update in this case. So again, the theory here is you want to get those OLED commands out of there, and you'll find it much faster. Now, this is such a common pattern that we ultimately we decided to create a component all around this, and essentially just all you do is you just kind of whack all this out here, kill that, and I just want to show you how easy it is real quickly here. I'm going to drag this upsert transform over, which is part of Task Factory, wire it up, and watch how easy this is. I'll spend 30 seconds on it. It's so easy. I'm going to create a connection. It requires ADO.NET connection here, so I'll just point over to my same database I have. I say 30 seconds. It's got to get. Helps if I can type it in. There we go. All right. So if I go ahead and hit OK, I point to my table I want to load. There it goes. Point to my table, which was transaction history. I wire up, check my primary key right there, and then I'm done. So all that code has turned into that one component. I'll run it. And this scales really well. It's about 800 times faster than the previous example we have. I have an example where I pull about 120 million records to this component. Now what's happening here is doing the exact same thing as that previous example was doing. It's essentially landing the data. It's doing the big set-based update, but all inside of one component instead. So that's the little Task Factory upsert component. but it's doing the same thing as what you saw back here. Undo, undo, and undo. So same thing as this, but landing the data just from one big component versus two components. Okay. All right. So the question again was, yeah. So how does it scale? How it scales? A whole bunch of questions here. We'll have to kind of come back to in a little bit here. So this is a way of kind of causing your dimension table, your upsert patterns to kind of scale a little better here. Now, hopefully, if you're doing that staging table, you have exclusive locks on the staging table at that point, and that should really make it where you're speeding that up quite a bit. Okay, so additional pieces where you can kind of tweak is really around. You saw when I was doing this component right here, when I was doing that conditional split, and I was typing, if this is equal to this, if this is equal to this, and this equal to this, and so on and so on and so on, I was getting a hand cramp over time. So this whole process right here, doing that for every single column, becomes extremely boring to type, and that's definitely a headset kind of moment right there. It's a really big pain in the butt. So one of the options we can do here is we can use something called hash bytes to kind of look at this and see what we can do. So there's a few ways of doing that. Let me go ahead and open up the table here. I'll just open up, let's see here, the club table again. Okay, I'll pull up student table. Let's see what we got in the student table. All right, so here we go. So one of the ways we can do this, let's grab maybe the first name and maybe the last name, and I'll pick the gender, something like that. And I want to find out when is something changed between these columns here. So I'm going to send this data set in, and I want to find out, hey, how does it look now? So one of the ways we can do that is we can go ahead and wrap all of this into a big old checksum. So if I were to do this right here and wrap it in like this and run this again, look what happens. What I'm going to get out of this, and this is one of two ways of doing this, we get a number that's all the way down that will tell us what is the value of these three columns unique, of these three unique columns. So is there the pro of this is it gives us one number that represents these three columns combined. The con of it is it sometimes is not guaranteed to be unique. So what we can do is we can go ahead and type in a hash bytes, and so this time we're going to go ahead and append all the columns together. Quite a little bit different logic. And this, the pro of this one is it's got a really high granularity being unique here. So we're basically hashing the data, much like you see with a lot of data stored in a database. So the data is now hashed, and because of that, we get a squid back. And the squid is pretty much guaranteed to be unique. So you don't have a collision in this case. The con of hash bytes is a little bit slower to get a hash than it is to get a checksum. So what you would do in this case is you would have, actually have an example of this actually, hash bytes. Here we go. So in this example, this upstart example, you'll see in my ODB source, I'm getting the hash bytes back right here. So you'll see right here where I have, there's my hash bytes right there, hash bytes in my ODB source. And I'm doing a pipe delimited there to make it where it can, and we can see all the columns combined. So I have my hash bytes there on my source, and then I do the same thing in my lookup transform you're seeing right here. So hash bytes there. I'm still going to connect based on my primary key, my alternate key here, and then I'm getting back the hash byte column right here. So ultimately, in my destination right here, all I'm doing is comparing, hey, is my source hash the same as my destination hash? If it is, I'm golden. So it's a way of, it makes this scale a little bit easier, and there are we actually have, and again, Task Factory has this hash transform right here. I think this may be one of the free ones also. There it is right there. And one of the things it does is it hashes data for you automatically, so you don't have to worry about hashing it manually like I did. So you can hash a flat file, you can hash an Excel spreadsheet, whatever. It doesn't really matter. There it is, hash transform. So I believe that's part of our community edition right there as well. So that's one way of doing it. And the question, when is hash bytes actually available? I've been using it since 2005. I have not used it before then, but I assume it's been available for a long, long time because of that. So it's been around for a long, long time. Okay, so hash bytes makes it where you're not having to to define that. There's lots of other options you have around this that we'll cover a little bit later also. Okay, so let's jump into our next slides. Okay, here we go. So the last piece here is really around a fact table load. How do we do a fact table load? So if we're getting data to load a fact table, what's going to look like is we're going to have all the alternate keys. So the key on our source system is sending us, all right, I have a sale for Brian, and here Brian was for $45. Here's Brian's alternate key. Here's his primary key from our sales system, for example. And here's a product he bought, and so on and so on and so on. What it's not going to hold is it's not going to hold the surrogate keys. So a fact table load is essentially a combination of a whole bunch of lookup transforms. For every surrogate key you have, you're going to have a lookup transform there. And then it's going to be a derived column transform at the very, very end, which its job is going to be to find to say, all right, I couldn't find this record. What do I do now? Do I go ahead and do an inferred number pattern, or do I set it to -1? So there's a couple patterns like that. Now you might have to aggregate the data up, but maybe you're at the product level and just want to see the lineup at the total sale level. Oh, sorry. So let's go ahead and try that real quick. I had an old sound there. It kind of scared the heck out of me there. All right. So here's what I got. And what I want to post on our blog later today is, let me go ahead and go to the location. Okay. I have a script in here called, okay, where'd it go? I'll post this today. It's called, I'm looking right, there it is. Create unknown record store procedure. This is a really cool store procedure. So you'll notice that when I look at my DIM student table, for example. Okay. Let me go to the right database, go to my data warehouse. When you go to my data warehouse and you look at DIM student, the first record in all my tables is this -1 guy here. This is my catch-all record. So if I get a transaction for somebody who I don't recognize, I'm going to go ahead and set it to -1 to somebody. Hey, I don't know who this is. All right. So because of that, I need to go and create this record in all my tables. And this becomes a big pain in the butt. Can you imagine Steve had a table with 400 columns in it? And can you imagine typing the word unknown 400 times for every single column in his tables? That would be a nightmare. So one of the things we can do is you can cheat with a store procedure called USP create unknown record. What's it going to do is it's going to point to club table. It's going to go ahead and create that unknown record if it doesn't exist or not. So it created one row was there now. Now I have nothing there. So I'm not getting any response back now. So what it did is it basically created that unknown record for me. If I were to type the word script here instead, it will ultimately show me the code it just ran. So it basically is a code gen tool for you. So I'll post this on the blog a little bit later today. It'll be on pragmaticworks.com underneath the blog section on pragmaticworks.com. This was developed by us a long time ago, but it helps create a lot of its code for you, so you don't have to worry about it. So now, if I were to look at DIM Club, okay, DIM Club, there we go. You'll see there's now a -1 record for DIM Club with a club name of unknown. Okay, so that is one option here for our fact table. So now I want to go ahead and load a fact table. So let's go ahead and hop back over to our slides. Not our slides, but our demo here. Let me open up this fact table here. All right. Okay, let me go ahead and start from scratch here, just so you can kind of see what this looks like. So I'm going to load the factless club table. So far, all I've done is I went ahead and I just have everything's aliased. Club ID, student ID, it's aliased as what they are in the data warehouse. And keep in mind, these are the primary keys from the source system, the alternate keys, in other words. But it's coming from my source system, not from the data warehouse. So now I need to look up for every surrogate key that I have. So I have 2 surrogate keys in this data warehouse table. The data warehouse table looks like this guy here. It's called factless club, if I can find it here. Oh, am I in the right? Yes, I am not in the right table. That's the problem. So here it is right here, factless club. There it is. Under columns, I've got a club SK and a student SK. Now, there's no measures in this case. That's why it's called a factless club. It's just that it's just showing it's a mapping table. Which students are a part of which clubs. So if I go into I'm going to add 2 lookup transforms. Okay. All right. So, oops, there it goes. Lookup, and I'll look up again. And let me go ahead and wire these up real quick. There we go. I'm going to send this to the matching output of this to go to the next one. All right, so let's go ahead and look at this. I'm going to ignore the failures. So if I can't find a match for my club table, for example, I'm going to ignore it. And let's go ahead and point to my club table. Again, I'm never going to select this top option in this case. I'm just going to do it the old-fashioned way. So I want the club AK and the club SK from my dim club table. Let me zoom in a little closer so you guys can see that. It looks like this. Oh, well, looks like an error. Huh? The reason why is I didn't point to my data warehouse. There we go. So there's one more piece I'm missing here. One big gotcha that I forgot. And that is I forgot to only get the active records. So I need where end date, in my case, is null. That's going to tell me that it's as an active record. So now I'm only getting the active records. So I have my club AK, my club SK, and I'm going to go ahead and my columns here and map those up. Club AK to club AK. Again, the left is my input data from my source system. The right is my dimension table. I'm going to get out the surrogate key, and I'm going to go ahead and hit OK. That's 1 down, 1 to go. So I'm just going to label that so I can keep track of which one's which here. I'll call this just club, and then I've got my last one, which is going to be student. So same exact process. This is a type 1 dimension. I'm going to ignore the failures. All right, this one's a faster one. We'll be lazy here. Select the student AK, and student SK from dim student. All right, let's go ahead and go to columns here. I must be doing something wrong there, and again, I am picking the wrong warehouse. I swear. All right, student AK to student AK, and get out the SK. So for every surrogate key you have, you're going to have the same exact pattern. Boom, 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 over and over and over again. So this is where staging data might actually make a lot of sense. And I'm going to show you some examples of that in a moment also, because if you have 20 different joins here to do, that's going to be a really, really long process. So our last step here is to go ahead and what if there was no club in one case? What if I got a null back? Well, in that example, I want to use a derived column transform to set that null to a -1. So it's going to wire that up. Okay, matches again. All right, let's go ahead and double click on that. And so what I want to do is I want to say, all right, so if the club comes back as null, go ahead and set it to -1. So is null club SK. So if it comes back as null, this is the good old-fashioned expression language for SSIS. A little bit insane, whoever came up with this. So it is if it's null, then go ahead and replace it with -1. Otherwise, what else is going to be colon? Go ahead and keep whatever the club SK says right now. So this is an if-then statement. If the club SK comes back as null, then make it -1. Otherwise, else, keep the existing value you have there. And I'll do the same thing down here for the student SK as well. Then -1, else student SK. Okay, so 1, 2, 3 punch. Now we should not be inserting any kind of nulls in the system. Let's go ahead now and send this to our destination. Okay. There we go. So that's our destination, and then our fact table is all done. So we got to point to the factless up in the data warehouse, Brian, into the factless club, and then we wire up all the mappings. Looks good. Hit OK, and let's run this bad boy. Now you'll see this process. It scales fairly well as long as those dimension tables are under 20, 30 million records. It's going to scale pretty well because I'm only getting those 2 columns, the alternate key and a surrogate key out of each of these data warehouses. Now this also is happening all in parallel. So the way SSIS works, keep in mind, is 10,000 rows at a time are coming through this. So as I'm pulling row 90,000 right here, roughly, keep in mind, Row 80,000 is being worked on right here. And row 70,000 is being worked on right here. And then row 60,000, other way around, excuse me, row 60K is being worked on right here. So all that is happening at the same exact moment in time. Okay? So this happened pretty fast. There's some cons though, right? Every pro has a con, and the con this time is a pretty big con. Let's run this again. Let's see if you notice it. What is a con here? Well, if you haven't guessed yet, my biggest con is I just doubled my sales here. So I ran it again. I have 8,000 customers the first time. I have 8,000 customers again the next time. And every time I run this, I am adding another 8,000 customers to my bottom line. So I wish sales were that easy, right? Just run it and load it and get the sales out. Unfortunately, sales aren't that easy, right? So that leaves this pattern. You have to do a few things, right? You have to either truncate the fact table ahead of the load, which is a big problem in some cases, or we need some kind of incremental load pattern of some sort. So the other alternative, and I'll show you the incremental load pattern in just a second here as we get into this as well. Before I leave the fact table though, there's one last option here, and Task Factory has the fact table destination. We got tired of doing this ourselves. I wire up the two lookup tables. It handles my type 2 dimension, and it handles my -1 record for me all automatically for me here. When I run this bad boy, it will basically do all that logic for me, and it also handles, if the row already is there, it will ignore the duplicates. So I can run this 5, 10 times, and it won't insert the same record over and over again. So you saw it's a pretty fast component also, and it's doing something very similar to what comments I see in the chat window right now. It is staging the data and doing one big fat merge syntax on the destination. So it's staging the data and doing 10,000 rows at a time versus one row versus one big bulk statement. Okay, so that's a fact table destination. All right, so let's go back to our slides again. So we covered some of the good things about the fact table load, but the biggest gotcha we had there is we need to basically find a way to only send the data that's changed in. So there's a few options we have there. Question here from Bob about the Task Factory. Where is the data staged, or where should we stage the data? It is staged onto a temp table in this case on the destination side. So that way we can use one big fat bulk statement. And you can change that, of course, you want to with a statement. All right, so the incremental load side. So I want to be able to identify which rows have changed between a certain time, between this time and this time. So imagine, for example, and this applies to whether you're pulling data out of Salesforce or whether you're pulling data out of SQL Server. It doesn't really matter. The pattern is going to be the same no matter what. So what I want to show you here is how do we avoid having to send all 8,000 rows every single time through our process. Instead, all I care about are the 15 rows that have changed, or in the 5 rows that are new. So to do this pattern, we're going to have there's 3 steps to it. But we're going to have a last modified date, or a create date, or an identity column of some sort. We'll need something to kind of key off of to make this pattern work. So this is the incremental load pattern, and let's kind of show you what this looks like. So essentially, let me kind of just draw this whiteboard real quick. We're going to have 3 tasks. All right, here we go. 1, 2, 3. So what we're going to do is we're going to build a table called our control table out here in blue. All right, so let's call this control table. Okay, that control table is going to have a row in it for every entity we have. So let's call this customer here. And the last time I loaded customer, so let's see here. I'll call this entity name, and then I'll have last load date. So we'll have entity of customer, and its last load was on 1/1 or 1/15, 2017 at whatever 4 p.m. And then et cetera, all the way down. So customer, we'd have sales, we'd have et cetera, et cetera. I've never loaded sales before, so it'll be 1900 in this case. Okay, so this 1900 is our default value in this case, meaning we have never loaded this table before. So these 3 steps. My first step is going to be a SQL statement, execute SQL task. Same with the last step here as well. What the first step does, it says, okay, I want to load the customer entity. When was the last time I loaded that entity? It will run a query saying, hey, when was the last time I loaded this? It's going to return the date you're seeing right here, and it's going to put that date into a variable that we'll use in a second. So I'll put that, I'll call it, last load date. Okay, so it puts that date into a variable I can store for later use. Now I'm ready to go ahead and load my data warehouse or my table or whatever I want. So I have this data flow task here. Now this data flow task is going to run a query. The first step is going to run a query like, select star from customer, where last modified is, greater than at last load date. Something like that. Now you're typically going to do a between clause of some sort, but we'll come back to that in a second. The last step is to say, all right, I'm all done. I've loaded successfully. Go ahead and update this table right here, and no longer is the last load date 115. It is now 215. So I'll go ahead and set that to 215 versus 115. So next time I load it, it will know to go ahead and pull any row that was updated since 215, not 115. And so on and so on and so on. So that's how this whole process was going to work. Those 3 steps. Now, there's a whole bunch of ways we can do these 3 steps, but essentially, whether you're using things like change data capture or whether you're using roll your own, it's still the same 3 steps. This is the roll your own example here. Now, by rolling your own example like we're doing right here, this control table you're seeing on the right could be something that we store in SQL Server for Salesforce.com, for example. So, for example, for Salesforce, they have a last modified date, and I have a list of all my entities on the right, and when I pull data out of Salesforce, I check this table, so I'm not pulling over all my Salesforce records every single time in a stage. I'm only pulling the 40 records that have changed. Same thing applies to dynamic CRM or even things like other kind of RESTful sources. Speaking of which, I'm kind of curious out there, guys. So we're talking about Salesforce.com and our dynamics, or maybe in some cases you might have some other kind of source on the web. I'm kind of curious, does your organization have any kind of systems on the web also? So we'll, I'll put a quick poll out there. So the last system modified date, yeah, Salesforce has this like last modified data in Salesforce. Other ones have some systems on the web also. It looks like most of you guys here have something on the web, it looks like you're hitting. Now, most entities out there that are on the web, most RESTful sources, have a last modified date you can key into. There are some like Raghav is pointing to one called sys modified date, which is what things like replication uses also. We can also use things like CDC, which we'll cover all those in a moment also. But it looks like more than half you guys, about 59% of you guys, actually have that kind of data. So you have data out in Salesforce, have data somewhere on the web that you have to get into your databases. We're finding this being a big trend out there in the world right now also. That's what we built in Task Factory. We built a REST source and a Salesforce source because we ourselves wanted data out of things like GoToMeeting. We want to find out how many people actually went to this webinar and how many people care about this topic. So we're using the RESTful sources in SSIS to get data out of GoToMeeting. So, okay, so that's the biggest requirement is we need that last modified date of some sort. And I'll show you other ways. If you don't have that last modified date, how can we get around that in a moment also? So we'll cover that in just a second. But you want to avoid loading all 6 terabytes of data every single time. So let me hop out real quick, and let's open up this control table example. So again, this same 3 steps you're seeing here are very similar steps you see in most components. The first step is, hey, tell me the last time. All right, show me the last load date from the control table when the table I want to load is equal to question mark. Now that's a variable in SSIS. Question marks represent some kind of placeholder I'm going to pass in. In my case, I'm changing that question mark under parameter mapping and to a variable called table name, string table name. So it's basically saying substitute that question mark with this table name variable. Now we'll see that table name variable right here, and it's called, my source table is called source table. Very appropriate name here, right? And, oh, sorry, I didn't mean to click on that. And so if I look at that control table right now, if I were to look at my control table, let's go ahead and get that real quick out. Let's kind of take a peek at what it looks like now. There we go. So if I were to take a peek at the control table, let me go to one that actually has it already open. There we go. We're seeing that the source table was last loaded, hey, this morning, go figure, I was actually kind of preparing for this session. It was last loaded, or last night at 8:59 p.m. So it's time to load again, and typically what I do is I also store things like, hey, the number of rows I loaded in this extract and all that as well. So the next step is I've now stored this answer. So I stored the answer coming back from this query into a result set. See the result set here, single row? I'm storing that into this variable here called DT last load, right there. So that's my variable I'm storing it into right there. So now I want to use that variable somewhere. So let's go ahead and use that inside of our data flow. Okay, so inside our data flow right here, we are going to run our query. There we go. You'll see. Now in this case, I have a little bit different query. So I'm saying, go ahead and give me the column names from my source table, and I want to get where the creation date was between question mark and question mark. Now the reason I'm doing a between clause in this case, if I go ahead and open up parameters so you can see it, the reason why I want 2 dates versus just 1 date, I'm saying give me all the rows that have come in to the system between the last time I ran the package, which is this one right here, and when I hit the go button on this package. I'm basically creating a window of time here. And the reason I'm creating a window of time, which is kind of keyed off the start time right here, is I didn't want to run this. Imagine this package takes 3 hours to run. Well, what happens with the rows that have been inserted while this package is running? I want to make sure I put a box of time in place to where I want all the rows from the last time I ran the package until when I hit the go button, and stop there, and I'll catch those next rows on the next run time. Okay, so that's why I'm creating this box, this window. I count the rows that are coming through me. I'm counting the rows right here with the row count transform, and then lastly I insert them into a destination. So those 3 little simple components. I might do some cleansing or whatever in there as well. Lastly, I'm going to go ahead and update the control table and set its last load date and the rows inserted. So I'm setting its last load date, as you can imagine, maybe, to be equal to the start time of the package. So that now I've kind of closed the window on the package run. All right, so let's go ahead and run this package and see how we look. So right now, out of the gate, we should see hopefully no records coming through. Okay, we'll see 0 records coming through because there's nothing in there. But you'll see over here, now I'm looking at Valentine's Day at 12:45. So let's go ahead and insert a few more rows into my source table here. All right, let's go to higher ed and go to my source table. Oh, it's called source table somewhere. It's too easy to see the problem. There we go. Let's go ahead and edit those rows. All right, let's go ahead and view these. Boom, boom, boom. I do about 8 or 9 inserts here. There we go, or 10, however many. And let's go ahead and run this again. Oh, I don't want to do that. I just ran that one component. Here, let's do this again. I made a mistake there. Okay. There we go, made a few inserts there. And let's go ahead and run the whole package. Oh. I am getting click happy today, looks like. Yeah, cancel that. All right, so 19 rows were inserted. We can now see in the control table that we had 19 rows inserted. The last load date was here. So if I run the package again, we should see no rows inserted. There we go. We'll see no rows coming down this time, hopefully. Beautiful. So what we're able to do is basically only get the rows that have come through. Now there's a few issues that we'll have with this. The biggest issue, if I pull this open, a source open again for Raghav and myself here, you'll notice what happens if a row is deleted here. So we're not going to be able to handle deletes. So occasionally, to Gary's question here, and it's a great question, we're going to have some kind of reconciliation that we do once a week, once a month, once a day, whatever it might be, where we say, give me all the rows that are over on the right side that are not on the left side. Now we have some third-party components in Task Factory that handle all those kinds of things, but it depends. Like in a data warehouse, you typically aren't going to handle, you aren't going to do deletes. You're going to handle things like you might do soft deletes where you flag the record as inactive, but you may not do deletes. It's a little less important on data warehouse side, but very important, as Gary's pointing out, on an OLTP side. So those records will remain in our reporting system because even though they've been deleted. Okay, which you may want. In most cases, you're going to want that. So again, just real quickly to recap here. I get the data from my source system. I go to my parameters. I say my first question mark is going to map to the last load data of this package. My second question mark maps to when I hit the go button on this package. Okay. Again, this session's also being recorded, so if you want to play it back over again, you can see it over and over again there as well. And also, all these examples and all are part of our Masters SSIS class. That's part of our training platform too, in case you're curious. All right. So this is a control table example. It's very, very commonly used. The route. Like for example, when I load Salesforce.com, I have these 3 tasks over and over again into a sequence container. So I'll just have a container like this, and I've got an entity for every entity in Salesforce. I have these 3 components, and I'll put the variables all inside of that, but I have it. I just copy and paste, copy paste, copy paste over and over and over again. If I can at least get these guys in there, I'll have all 3 of these components. It is refusing to go in there, isn't it? Oh well, you get the idea. So I have all 3 of these components all inside over and over and over again for each of these components. So kind of a handy way of doing a Salesforce load. If you have Salesforce or have system on the web, you would have 1 per each entity that you have. Okay. All right. So good spot there. Let's go ahead and jump back into our slides. There's one more way of doing this, which we're not going to cover 100% of right now. I just want to let you know, allude to it being there for you as a tool, and let's kind of cover the architecture at least. And that is the change data capture component that you have in SSIS. So change data capture, or CDC, gives you the ability to where you can go through, and it basically requires enterprise edition of SQL Server. Now they're doing some stuff to make it a little bit easier also. Now this is essentially using replication behind the scenes. And what it does is when you turn on CDC on a given table, change data capture on a given table, you're telling SQL Server, watch this table for any kind of changes that might occur. And if a change occurs, it will copy those changes into another table, a CDC table. And it will tell you, hey, this is a new record, this is an update, this was somebody deleted this record. So it keeps track of those deletes for you in case those kind of events happen. So CDC is a really, really handy way of doing those kind of temporal kind of views of your data. It uses agent behind the scenes, SQL Server agent behind the scenes, and it's a really, really good example for that. I have an example in my over here. It scales very, very well. It uses less than a point of CPU to do all this mess. I've never noticed a big difference on CPU. But you'll find that SSIS actually has built-in components for CDC that make it easier to do this now. These are actually components that they got from a vendor called Attunity, and it's built into SSIS now. And you'll see, once it comes up, I'm not actually going to go over these, but you'll see basically the same 3 steps, right? I want to start the package, I want to load the data, and I want to mark it as not done. It's doing the same stuff that we did with our other 3 components, but using CDC instead. So you'll see it right here. This is another example right here, right? So I'm saying, give me the range of data that I have to load right there. So CDC right here. Oh, come on. It's locked up right now. That's why it's validating all this. So it says, give me the range of data that I can process. Load the data, and then mark that table that I'm actually done this now. So really quickly, I just want to show one piece of this to you, though, and you'll notice that instead of a control table, I have a table, a different table here called CDC states. It is exactly the same thing though. So the same 3 steps that we have here are all done the same way. So a question that we often get asked here is how do we deal with changes from a CSV file, for example, or an Excel file, or something that's not a normalized system. In those examples, you're a little bit more at the mercy of those. So it's going to require that you use more that upsert pattern that I showed you a little bit earlier. So let's imagine instead of this being a table, this was a CSV file or an Excel file. In that case, you would do a lookup transform against your table, and then you would send updates one way, inserts the other way, and duplicates out to the drain the other way. So there's lots of ways you can do that, but the upsert pattern is probably the way you're going to ultimately solve that problem for the people that are asking right now in the chat window, that one. And that's also why the upsert transform, that's why we built that component also, was for making it easier to do that as well. That was a question from Emilio. Let's actually answer a few questions for the next 2 minutes here while we're getting ready for our next break. Let's see, what happens if the source does not have a modified, a creation date? That is a question, the ultimate question there, right? So if your source system does not have a modified date or creation date, we're either going to have to do CDC, like you saw. I pulled up that example in the slides here, right here. So we can do CDC on the table, and it will watch for that, and it'll create that example. But I have enough questions here. Let me actually try to show what the code looks like real quick here. I'm going to go ahead and create a database here called CDC demo, and it's going to be a basic table here real quick, and I'm going to load a few rows into it here just to kind of get some stuff going here. Okay, it's all done through T-SQL, unfortunately. Okay, so I'm going to go ahead and turn on CDC on that database, and then I'm going. This is store procedure here. CDC enable right here. Turn it on the database. Then I'm going to turn it on the table here, and this I'm turning on this person address table here. Okay. Oh, agent's not running. So it's telling me, hey dummy, you didn't turn on SQL Server agent. So let me go ahead and turn that on. There we go. All right, give that a few seconds to start, and it's in the background telling me, are you sure you want to start? Yes, let's go ahead and start that. All right, with that now done, it's going to ultimately create 2 jobs for me. It'll create a job to capture the changes and one to clean up the changes. So it keeps those changes out there for a number of days. You can change the number of days you want, and then it's going to capture the changes in real time, essentially. So now, if I go ahead and select against this new table it created here called person address CT, this is a system table it created out there inside the CDC schema. It created it for me when I turned on CDC. Notice there's no data out in that table. So if I were to go ahead and insert a few new records into the table, there we go, I'll insert 3 records, and I'm going to update 2 records. Okay, let's go ahead and query that now. So now, let's do no data out there yet. I'm going to run it again a few seconds later. Now data shows up in the table. So we have, notice the operation here. The operation, a 2 means it's an insert. A 3 means, a 3 and a 4 is an update combo. 3 being the before the update, and 4 being after the update. What did the row look like before you updated it, and what did it look after you updated it? And it shows us, here's the row right here. Here is the operation, and you can even see over here is a way of actually getting the actual columns that were updated also. So you can actually find out, was it a type 2 column, was it not a type 2 column? So this all comes down to the question of what if I have a vendor system and I don't have a last modified date. It's one of the ways you can do that. Now, almost every database platform, Oracle, DB2, they all have a system like a CDC example out there. It gets very elaborate here. I can go into it much longer. I'm not going to go into it much longer than this. But just note that it ultimately, every database platform out there pretty much has a CDC kind of concept out there. So this is roughly how you can do it. So you would wire up to that table inside of SSIS right here. Okay, that's right into that CDC load right here. Now the question we get asked is, you will only have one CDC states table. It's just like your control table earlier as well. The CDC states table basically keeps a row in there for every table that you're monitoring, essentially. Just like the source table we had also. So this is an example we go into deeper in our Master SSIS class. There are some performance consequences of it. Yes, there are some great white papers. We do have white paper in our performance material that we have a little bit later we'll share, but it's not that bad. I have almost never seen a performance gripe about CDC. So let me go ahead and we have about 3 minutes left. Devin, do you want to do a quick after the break or before the break?
Yeah, let's go ahead and do it really quickly before the break while we have everybody here. I'll flip over to myself for just a moment because what I'd like to do with you guys before we go into our last 5-minute break of the little workshop here, the virtual workshop, is talk a little bit more about our on-demand training. I know I gave you an idea about what our on-demand training was previously, if you happen to join us in our previous break. But if not, it's training that allows you to actually go much more in depth than anything we can possibly offer in a webinar, even a 3-hour webinar for that matter. But what I'd really be curious from getting from you guys, now that you're sitting in here with us, is what kind of topics you're interested in. So we have quite a few core BI topics, as well as SQL Server, like SQL Server High Availability, DBA Fundamentals, and then we have SSIS, RS, AS. But I'm curious in what you'd like to see in the future. So I'd love to have you guys help us shape what our next set of courses are like. So the way I'd like to do that is by telling you briefly about what we have on our roadmap. So what our roadmap looks like as far as new content, and then you guys can kind of help me understand what's probably the best next set of courses that we can do. So just to give you an idea of what we have on our roadmap, I mentioned a couple of these previously. Some people actually posted in the chat window they were interested in a few. For example, we're going to be working on an enterprise data modeling course. That enterprise data modeling course will cover not only topics that you heard about today, like how to build out a data warehouse, it'll also cover building out transactional systems or OLTP systems. We're also going to be developing some more Excel content, so things like building out Excel pivot tables. So if you have end users that are actually using and developing pivot tables off of analysis services cubes or anything like that, we'd love to. We'll have a course for that coming very soon. We'll also be doing an Excel modeling course, which is more around things with some of the key functions of Excel and how you can model them inside of Excel. And then some courses we'll have in the future are going to be the ones like an introduction to Tableau. So if you have any folks that are actually using Tableau at your organization, we'll have a course for them. Loading a data warehouse, master data services and data quality services, and then PowerShell as well. So we have quite a few that are coming, and then I'd love to hear from you guys, and you're welcome to put this in the question box if you'd like, or the chat, is let us know what other courses you're interested in. I saw one person ask about Power BI courses. We actually have 4 separate Power BI courses already, but there's a good chance we could come out with some others. So if there's some very specific topics within inside of Power BI you'd be interested in, please let us know. So as we're going into the break, I'm going to put a 5-minute timer up on the screen. Feel free to, as you have any other ideas of courses that you'd like to see or that would help your organization, even if it veers slightly away from Microsoft, as long as it deals with data, we are interested in working on those. So please give us some feedback in the question, and I'm going to go ahead and, like I said, put a 5-minute timer up, and I'll be reviewing those as those come in. I appreciate it a lot. Thank you. Hey guys, as we're coming back the last few seconds here, I appreciate the feedback. That's actually really, really helpful. So if you have any other course ideas that you're interested in, please keep putting them in. You can also, if you think of one later, just email training@pragmaticworks.com, and that'll also be helpful. I appreciate that.
Well, welcome back, guys. I appreciate it also for you guys coming back. We are down to our last section of the day. So actually some really interesting course examples here. Looks like I like it. Also, so a few guys asked for demos of more task factory pieces. Yeah, if you want that, please feel free to send me an email. Excuse me. It's b9@pragmaticworks or hit sales@pragmaticworks, and we can do a custom demo for you guys also. That's not a problem as well. Okay. We had a lot of questions here. I'll get to you right now, at least some of those. So the first one was, when do we use ADO.NET versus OLADB? This is from Mr. Khan, or Moise Khan. That's a great question. Typically, you're going to use OLADB. It performs slightly faster than ADO.NET, slightly, because they're catching up, but it's only slightly different right now. So the ADO.NET connection is required for some of the newer components. So a lot of the Task Factory components, the CDC ones you see here, some of the Microsoft ones, all require more of an ADO.NET connection. So if you can get away with it, do OLADB. If not, then ADO.NET's one to go with. I saw about a 5% decrease in performance by going to ADO.NET a long time ago. That's been a while since I tested that. Let's see here. I'm not sure what the, okay, so these are topics, I guess, excuse me. All right, let's see. I'll have to clean this up a little bit here. I had a question about the CDC states table. This table here that we're storing, we're going against here, is the same kind of table that we did with the control table. We would have a row in this table for every source that we want to pull data from. So that's another example right there as well. All right, well, it looks like that's most of the questions. I'm getting lost in questions a little bit because they have all the class examples as well. So, what is it? Okay, here's a great question from Patel here. Prabal, is it preferable connection to you? Okay, so what's better as far as performance, ODBC or a link server? You should almost never use a link server for pulling data up because it's not as reliable as we'll find in things like SSIS. You'll find you get occasional timeouts, you get things like that might cause occasional problems. So be careful on link servers. ODBC or OLADB would be preferred. Eventually, Microsoft has stopped investing in OLADB, so you're going to see ODBC being the primary vehicle going forward, but we're not there yet. So it's got some time before they actually get there. Okay. Yes, and you are correct. In 2016, they actually did lower the version that CDC required. It required Enterprise Edition 2012-2014. Now it is actually a lot more availability now. Okay, so a lot of good questions here. Okay. All right, so let's go and jump into, I have so many of them actually, it's hard to keep up. Let's jump back into our slides again. Okay, there we go. Okay, so if you've been in IT for longer than, call it 10 years or so, you've noticed that actually a lot of these questions we're getting right now are actually pertaining to the section. It's good timing, especially Ryan's question we just got there. A lot of these, if you've been in IT for longer than 10 years, you know that if I were to tell you 10 years ago that we're going to put a terabyte data warehouse in a SQL server back in the 90s, you would have been laughed at, right? It's just not a good thing at the time. Yeah, but nowadays it's very, very common. All the database platforms are roughly the same thing. They all can support multi-terabytes, but they also all have a much condensed window to load data now. Before, you might have been able to load the data and give it 5 minutes or have five hours at night. Now, in a lot of cases, a lot of hospitals have a maintenance window of 20 minutes, 15 minutes to get the data in for a warehouse load. So it's some big issues we have, and that's what this section is all about. It's all about how do we load data faster, how do we load more data faster, basically. We have a whole bunch of use cases around that. Okay, so let's start with some of the data source side. How do we tune the data sources? Well, the biggest bane of SIS is going to be doing things like sorting of data, and we'll cover that why that is in a moment. But the biggest thing to keep in mind is don't be afraid to use T-SQL. So things like sorting data, joining data, filtering, doing where clauses. The old term is if I had a hammer, everything's a nail. So you want to avoid that whole concept when you're walking around SIS trying to load data. You want to make sure that you're just not using SIS because you can use SIS. Sometimes it makes sense to do things like a staging table in many cases. So let's cover some of the ways of doing the sorting here, for example. So you'll notice, let me go and hop out over to here. Okay, so if I were to open up my CDC example right here. Okay. Okay, so first of all, if I were to, this in-figure component right here requires that the data be sorted that's going into it. So if I were to do that right now, I would need to put a sort transform between these two components. Matter of fact, I'm going to go ahead and hop in and actually do that real quick. So I would drag a sort over here, drag a sort over here, and wire those guys up. I would sort by the club AK, and you see I'm spending a lot of time on this, but it's taking a little bit of time to do this, and it's not necessarily the best way of doing it. Here's our problem here. And things like the merge join requires it to be sorted. There's other ones that require it to be sorted in that case also. The sort transform is a fully blocking component. Think about a deck of cards. And I hand you a card, and I say, I want you to sort this deck of cards. You can't do that until you're holding all the deck of cards in your hand. So as data is coming out of these two components, it has to have the entire data set in memory before it can move forward. So imagine this. I've got a whole bunch. Let's take the sort out here. Let's imagine. I'll just go ahead and, so we don't get confused here. Let me go ahead and delete the sort here. So imagine I have a whole string of components right here. Okay, and it looks pretty bad here because I have terabytes and terabytes. Oops, arrow went the wrong way. I have terabytes and terabytes of data I'm trying to get from here all the way down to the bottom. So what happens in SSIS is data comes out in 10,000 row increments or 10 megs, whichever comes first. And while this is happening, as everything is coming down here, if I'm working on row 100K right here, I might be working on row 90K right here, row 80K right here, and row 70K right here. So everything is all working in parallel to make this work. So this works beautifully if everything is synchronous. Now, if we throw a sort transform out here, now I don't, what I needed 10, 20, 30, 40 megs before to make this 2 terabytes of data load into SSIS. Now I need 2 terabytes of RAM to make this work, because a sort transform has to see the entire deck of cards before it can do things. So that's why you want to avoid using a sort if at all possible. Now the way you can avoid it is, of course, going up here, adding an order by clause into your component. Now this is not good enough. The order by clause is not good enough in SSIS. You have to tell SSIS the data is sorted also, because this could be a store procedure, it could be a view, it could be all those types of things. So if I were to open this up and go to the advanced editor, this is how we tell SSIS that it is sorted. I'll go to input-output properties, and on the source right here, the computer, this is the advanced editor, so I right-click and went to the advanced editor. This is going to show, I'm specifying that at the green, this is my green line, our blue line, this is my red line. And I change on my blue line, I say the data is already sorted. So by specifying that, it now knows the data is sorted by something. Then under output columns, under the club AK, I'll specify that I'm sorting by this column first. Now I could say I'm sorting by the second column second by saying 2 on the next column, or that is an ascending sort right now because it's positive 1. I can also say make it a descending sort as well, which is a negative 1. So this is an easy way to make the sorting happen instead of SSIS. It requires a little more work, But the difference is a huge gap. If you're pulling millions and millions of rows through, the difference might be for 100 million rows, it might take you 10 seconds with an order by clause, but it might take you 8 to 10 hours to do a sort transform. So it's a huge difference in time to watch out for. Okay? So try to avoid using a sort transform and instead use T-SQL for what it's good at and letting SSIS know what it's good at as well. Now the other option is for a flat file. There's this notion of a fast parse. Okay? So the fast parse option is basically saying that, all right, SSIS, I don't want you to parse the data. So what happens? Let me open up this real quick and open up fast parse. Where'd it go? It's somewhere under, right in front of my face here. There it is, right in front of my face. I thought so. Okay, so let's look at this connection manager that we see right here. It has a couple million records inside of it. And what's going to happen in SSIS is it's going to parse all these columns to make sure that it's actually a true number or a true date. So this applies to numbers and dates. So if you have a file that's rather large, millions and millions of rows in depth, this setting applies to you. If you don't, then don't worry about it. Okay? So what this is going to do for us is it's going to say, all right, I got the data from the database already. I trust that this data is good. So what it's looking for is the parsing is looking for. It's saying, hey, do you have the value of A coming in this integer column, or do you have a 229 February 29th coming in? So what kind of bad data do you have? It's trying to filter that bad data up front versus on the back side. So if you trust your data, that's a big, big if, right? If you trust your data, then what we can do, there we go, then what we can do is we can turn on fast parse. Now let me show you what it looks like before without fast parse turned on. Let me go ahead and run this, this data flow here with fast parse turned off, which is the default behavior. Okay, so we can see it's loading pretty fast. All right, there we go. So it ran the million rows fairly fast. Most people are going to be upset by 7 seconds. Now keep in mind, this applies to much, much larger data sets here in this case. It used to be, this example was when I didn't have a solid state drive, the million rows would take about 30 seconds to run. It was much more impressive. But let's look at this, how we turn it on with fast parse on. The first thing we have to do is the exact same package, and then we're going to go ahead and go to the advanced editor again. The advanced editor is all the stuff that Microsoft doesn't necessarily want you to see. It's the stuff that is kind of hidden behind the scenes that wouldn't be very useful inside of a user interface. So in this case, what we're going to do is we'll go to the input-output properties. We'll pick some columns. This column right here, for example. And as we select each column, we could turn the fast parse property on right there. By turning that on, what's going to happen is it's going to skip the parsing of that, and it's going to save about 15% per column by doing that. So if you have large flat files, this will save you a huge amount of time by doing that. So let's go ahead and see what happens now. All right, let's go ahead and run this bad boy. And we were at what? How far before? 8 seconds roughly, we'll call it. Now, with fast parse turned on, let's see how fast we do now. Okay, much, much faster. Let's see how it felt faster at least. Let's go back over to our progress pane. So it went from 8 seconds down to about 3 seconds. So you can only pull data out so fast from a flat file, but it looks like, at least as far as SSIS time is going, it's speeding it up quite a bit. Okay. So this is an easy way to get a connection to go a little faster. Now, the other piece is if you're pulling data out of a large database, whether it be DB2 or a SQL Server, excuse me, Are you pulling data out of DB2 or SQL Server? There is a whole process around TCP/IP. So let's imagine we have on the left side, we have DB2. On the right side, we're trying to get data into a SQL Server over here. Now think about all the stuff that's between those two servers right now. So between those two servers, we have at a very minimum, we're going to have a switch right there, right? All right. Now what happens here is SSIS is going to get data out, and my SSIS is running right here on the SQL Server in this case. And it's saying, all right, DB2, give me some data out. I'll do this in green here. Well, do I have green? I can't see it. There we go. It's going to say, give me some data out. All right, so the first inquiry out of DB2 is going to say, all right, well, how fast can you talk, DB2? Can you go, how big of a bucket can you send me data in? DB2 is going to respond saying, all right, here is some data. I acknowledge your request, and here is your first 4K data. Boom, back and forth. I acknowledge I got the data. All right, and so it goes back and forth, back and forth. That process takes a long time, and the default amount of packets it will do is 4K at a time. So if you're getting terabytes and terabytes of data out of DB2, out of SQL Server, it will take a long time to load that data. So we need a better way of doing this. And one of the better ways of doing this is to increase our network packet size right here. Packet size. And by doing this, it's ultimately going to give us bigger buckets over the network than the small buckets we normally get in 4K. So let's go over, first of all, to where we see it. So let me open up any package here that has a connection. There we go. It has a connection. So let's imagine we're trying to pull data out of higher ed right here. Now, if I open up this connection here, you'll notice under the All tab, there's this one property under the All tab. All right, it is called, okay, oh, there it is, packet size. It's right here in green. And by default, it's set to 0, which means don't set it all. We'll rely on whatever the server tells us is what we want. So the application is not going to request any more than 4K. So we need a better way of doing that. So one way of doing that is we can bump it, if we have a lot of data, to the highest number possible, 32767. That's the highest number we can throw in that value right there. And now this is going to be sending a lot less packets over the wire from over SSIS. So the connection string is going to change if I do this. So let's kind of show you the connection string quick. I'll put this 32767. I'll hit OK. Now my connection string now looks a little bit like this. Let me go to Notepad here so you can see it. There we go. And now you're going to see the connection string has packet size equals right there, 32767. That same property works for DB2 and Oracle as well. It's something similar to that in each of those platforms. Now by doing that, what's going to happen is we'll be sending much bigger buckets over the network. And so when we did this at a big customer had DB2, for example, we were pulling about 2 terabytes a night over the wire. Our extract, just from a networking perspective, went from about a 45-minute load to about a 15-minute load. So it was as close of a thing to a silver bullet as we can find to get data over this. Now it required a lot of work, and the work it required is this. You can set this connection string all you want, but the network card might not comply by it. So in other words, let's look at my own network card. Now this is a laptop, not a server, mind you, but let me look at my network card here. I'm plugged in, there I am. Okay, and let's go to my network properties here for the adapter. Now even though my connection string is saying, you know, fully load me up, 32K, it's the lowest common denominator is always going to win. So for example, if I have I'm trying to send a Ferrari down dirt road, it's going to go with the dirt road pace. And that's what we have here. So if I were to go to configure my network card here and look at the advanced properties, one of those properties is called jumbo frame. And you'll notice in my case, it's actually turned off on this network card. Now keep in mind, this is a laptop network card, not a big server one. But with that property turned off right now, it's going to ignore that I'm asking for larger packets and downgrade me to the lowest common denominator. If DB2 had the same setting, or the switch had the same setting turned off, it'll decrease you to the lowest common denominators. So switches absolutely have to allow you to have jumbo frames turned on. Otherwise, this is no good at all. There's no value at all in doing this setting. So here's the bad part. You got to work with your network administrator. So you got to bring him or her some beer, and ask them to work with you on setting these settings correctly, at least on a local private network here, to where you can get data out of your systems faster. Okay, but once you get it, it will make your system run much, much more efficient. I would only do this if you have large amounts of data, hundreds and hundreds, maybe millions of rows to get over the Wi-Fi or over the network. Okay, so that's called the network packet size property. You set it on the destination and on the switch, and on, of course, your machine that you're pulling, or your SQL Server as well. You want to get it on all three settings. Otherwise, you won't pull data over at an optimal level. Okay. The other piece, I had a question in the chat window a little bit ago. Hopefully, Salita, I think I answered your question there. I had another question in the window earlier, which is actually pretty pertinent now. How does compression affect SSIS? Well, compression is utilized all over the place in SQL Server now. Where before was if I would go to a class and I would ask how many people here are actually using compression. Typically, I would get maybe one hand out of 100 that would go up. Compression does some amazing things, though. Compression will ultimately allow you to pull data out of a SQL Server so much faster. So with compression turned on, there's two types of compression. One is a page compression, which will compress each page, kind of like a zip program does. And also one is a row compression, where it compresses the data type. So I have a varchar 20. I'm only storing 5 characters in there. It'll compress that down for me immensely. Or I'm storing the value of 1 into an integer. It will compress 3 bytes of that to give you only 1 byte out. So page compression is one that most people use. I have a repeating value, Brian, over and over again. It compresses that into 1 value and has a check byte in there for you. So the pro is you can get a huge impact on your select queries. So pulling data out of these systems is much faster for you. All right, so the con is insert performance goes down by about 20 to 30%. So select performance goes up. I have that one big example I mentioned with the jumbo frames earlier. There, by turning on compression, we got about 175% gain in query performance out of pulling data out of our data warehouse, especially our fact tables. However, pushing data into those warehouses, tables, went down by about 30 points. So it's important that you know that when you do this, SSIS performance will go down on one hand. However, it will go up potentially on the other hand as you're pulling data out. Okay? All right. Could you explain something different? Okay, so as we go through this, let's kind of go through this one more time here. So really quickly to compress this data, and Jennifer, I got your message. I will answer that question in a moment here. To turn on compression, really simple. All you have to do is you just right-click on a table, and you go to Manage Storage, Manage Compression, and then you can basically build a script here. Say I'm going to turn on page compression. Hit Calculate, and it shows you the savings you're going to get from it. In my case, it's about, oh gosh, a pretty good savings in size, about half the size. Typically, you get about a 3-to-1 compression ratio is pretty typical for this. Now, when you compress the data, you can also, the middle ground could be to have a partition table where the current data, current month, current week, whatever, is uncompressed, and all the old data is compressed. So that's a middle ground you can do to see about getting data, in both areas. Okay. So let's hop back over here. Now we talked about the transform performance before, about loading data into buffers and escorting it from step to step. Now this all applies if the data is synchronous. You'll notice that there's actually 3 buffers being worked on at any given point in time. If the data is synchronous, all those buffers are all being worked at any given point in time. However, if it's not synchronous, there's a few components in SSIS that are not synchronous. It will cause an accident like you see on your screen right now. So an asynchronous component means it's blocking the data somehow. Now there's two types of blocking components. One is a partially blocking and one is a full block. The full block will be things like the sort transform. Think about that deck of cards, right? I can't do the sorting that you want me to do unless I have all the cards in my hand right now. Another one could be like an aggregate transform, where I need to sum all the cards. Well, I can't sum all those cards without having every card in my hand also. So those are the two challenges we have. Those components can give you grief around that. So there are also some partially blocking transforms. So the partially blocking transforms are where it basically is going to empty the data into a new buffer, a new memory bucket, and send that new buffer on its way down. So it blocks a memory buffer at a time. Keep in mind, a buffer of data is 10,000 rows or 10 megs, whichever comes first. So that partially blocking transform would be things like a union all transform, where it has to create new buffers on the way out because the metadata might have changed there. Okay? So what this might look like is this. If I use this partially blocking transform right here, which you'll see in the union all transform right here, I was 105 seconds before. This case study here, I sent about 100 million records, and the performance went down by about 15 seconds by me adding that union all transform. So the union all transform, it's not that you should avoid them, but if there's a way alternative coding pattern around it, then try to do that if you can. And my alternative pattern here is basically to ignore the lookup failures and do an if-then logic inside that drive column transform. Okay. So now we're getting the destination side. Oh, first of all, let me go back here on this one piece here. The question oftentimes comes up. Okay, let me open up a, here, this will work here. Let's kind of pretend that we have a data flow here. So there's a few properties here I want to show you just so you know they're here. All right, here we go. All right, this is what controls how big the buffers of memory are going to be for you. Remember, it's 10,000 rows or 10 megs, whichever comes first. This is in bytes right here, by the way. It's 10 megs or 10,000 rows. The number you may want to tweak is the 10,000 row number. Now, I only tweak it if you're seeing problems in performance. The right number is usually between 8,000 and 12,000. It's probably the right sweet spot for most companies. So that's why 10,000 is right in the middle. It's a perfect number to start with. But if you have a package that's taking more than 10 minutes to run, then I would try adjusting that 10,000 rows, maybe 8,000. The wider the table, like I mentioned that 400 column table we talked about before, the wider the table, the lower that number should be. We want to try to get that buffer going as fast as we can. The narrower the table, the higher the number should be. We have some spreadsheet guidance on our blog that kind of walks through, here's what the schema looks like, here's how many rows I have coming in, how do I adjust this. The last setting here is engine threads. It should be pretty much a black box setting, but there's a few reasons why this might come into play here. Let's imagine, for example, let me copy and paste a few times. Boom, 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 boom. All right, here we go. I have a whole bunch of sources. When they use things like the import-export wizard, for example, it looks like this, doesn't it? It creates a whole bunch of sources and has a line going from here to the destination over and over and over and over and over again. Each of these sources, each of these lines here that are coming out is going to require a memory buffer. So let's go back to this type 2 dimension here again. Am I there? I'm actually there already, excuse me. All right, so if we kind of look at this right here, something simple like this. We have one buffer being used right here, and then we branch off. So now we're using a second buffer here and a third buffer here, and then we kind of join the fray again. So we have a new buffer being used here because this is partially blocking, and we still use that buffer 4 right here and down, and we still use buffer 2 right here. All right, so buffer 2, buffer 1. So as you can see, we're using about 4 buffers for this, 4 memory buffers, or 40 megs of data for this example right here. Now, 4 buffers in total flight here. Anyways, the challenge we'll have is if we have a whole bunch more branching. So let's imagine we branch this way and we branch this way and we do a whole bunch of junk and a whole bunch of different threads right here. So now we're down to, we have 1, 2, 3, 4, 5, 6, 7, 8, and so on and so on and so on. So if you have a package that looks like this, where it's doing branching and branching and branching and branching, so on and so on, it's gonna stall at some point. And you may notice that the behavior behaves this way. Things are working all beautifully all of a sudden, and then all of a sudden it stalls. One day you get a call in the middle of the night for that process stalling. What's happening is you've run out of buffers, and it's waiting for a buffer to free up, and it's caught in a loop because of that. So if you ever see stuff get hung up, like right here, where I'm highlighting right here, and it's not moving on, it's because you've run out of buffers. So you may want to adjust the data flow property over here called memory buffers, which is set to 10 by default, at least in this version of SQL Server. So to think about that, don't adjust that unless you really see a reason to adjust it. But by adjusting it, it will occupy more resources, more CPU threads to do that. But you want to very rarely have to occasionally do that if you have a lot of branching code logic, really large data flow, for example. Okay. The other piece in the control flow property, all right, let's go down here. Okay, it's always kind of a little bit hidden here. I have to kind of, there it is right there. The other example here on the control flow, basically the equivalent of that in the control flow is max concurrent executables. This is telling us how many tasks can run in parallel inside of SSIS. And you're noticing it's right now set to -1. If I were to put the value of 4 in there, and I had, boom, 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 and had 5 tasks running in parallel, these first guys here would run first, and this last guy would wait for a thread to open up before it can actually run its task. So this is a way that SSIS kind of controls to make sure it doesn't eat too much of the time on the server. It doesn't pound your server too hard, in other words. I got cocky one time. I was pulling data out of a mainframe, and like, oh, I got plenty of resources here. SSIS is hardly being touched right now. I'm only at 10% utilization. I want more. And all the tables from the mainframe had no relationships involved. So what I did is I set that max concurrent executables like 25. It's getting kind of cocky here. Well, it ran beautifully. On the SSIS side, my utilization went to like 60%. I was pulling over all the mainframe tables at the same time. However, I was killing the mainframe. The mainframe was going to its knees, and I didn't even know I was doing it. So at least my process was. So I got a knock on the door shortly thereafter, and asked me to stop whatever I was doing. So this setting is one that should be kind of be careful with it sometimes, but it is kind of useful to have a whole bunch of things that are running, like a Salesforce load, for example. And you want to pull data out of Salesforce, and you got a whole bunch of unrelated components you want to pull over as fast as you can, then set that setting. What -1 means is it means I want you to run however many cores you have. So I have 4 cores on this laptop, so 4 cores are going to run concurrently plus 2. So 6 tasks can run in parallel. So it's 2 plus the number of cores that you might have. That's what the -1 means. So it's a dynamic number. So as you go from dev to QA to prod, and your server gets bigger and bigger and bigger, you can run more tasks in parallel because of that. Okay. I had a question also, I had a few questions about this also earlier, is tell me about this protection level property right here. So it's a number one thing that we see people make a mistake in at Pragmatic Works, and also just at ourselves. We make the same mistake also. Here's the behavior you're going to see here. The package works great in your environment, and dev and QA it works and dev it works beautifully as long as you're dialed in. And then the minute you deploy this to QA, the package ceases to work. So how is what's broken here? This is a question from Jennifer, and among other things as well. So she's in a team environment, and this is what the problem that she has. You want a little guidance on this, and I have a few other questions about the same thing here. So the encrypt sensitive with user key, what that means is it's going to encrypt the package, all the protections, all the secret stuff inside my package. Like passwords, any kind of encryption keys, all those kind of things are locked down with my user key, my credentials, my Windows credentials on my machine. So it works great on my machine. I deploy to QA, the package fails. And you would get a login failure essentially, saying it can't connect to Oracle or DB2 or or SQL if you're using SQL authentication. So that's a symptom you have to get around. So encrypt-sensitive user key is not a good option in a team environment unless everything you have is using Windows authentication and no passwords were stored anywhere in this package. If that's not the case, for a team environment, I prefer to use either encrypt all with password or encrypt sensitive with password, and then share that password, a simple password, with the entire team, and that password is stored right here. That password can be reseated whenever you go to deploy these packages to production, and all it's going to do is whenever you open the package up or whenever you schedule the job to run, it'll ask you for a password, and then you're all set. It'll schedule it, and then all the encrypted data is now available for other people to see now also. If you don't do that, if I pass you a package that has encrypt sensitive with password, it will wipe out all the sensitive data every time you open that package until I go to your desk and type it in again, or until you type it in and hit save. Now I can't touch it. That's why the only option really for most people are those two options I have boxed right now. Okay, Jennifer, I hope I answered your question. I've dealt with that quite a bit, unfortunately. It's a pain in the butt from a team environment perspective. All right, so let's go over destinations a little bit. On our last little bit here we have. So on the destination side, how do we make this run a little faster also, or a lot faster, hopefully? We mentioned the fast load being an all or nothing thing as well. Now, of course, all the old T-SQL concepts all still apply. If you're inserting into a table with no indexes, for example, or no keys, it's going to load much faster than one with keys. So keep in mind, fast loads are an all or nothing thing. There's lots of things that we can do around that fast load. One thing to keep in mind is where you run your package might matter also. So if I'm running on my laptop and I'm moving data from SQL Server 1 to SQL Server 2, the data is actually going to come over from SSIS 1 and be crunching all of that data on my laptop before it sends it to SQL Server 2. Now if I move that over to SQL Server 1, now it's going to cache it there or cache it there. It's up to you. So where you run your package might matter. Now it's a lot easier now than it used to be. Before, now you can deploy to a server and run it through Agent. So if I were to open up Agent in 2012 and fire off a package, it's no longer going to run on my laptop. It's going to run it on that server now. But if I'm running in Visual Studio, it is running on my laptop. So something to keep in mind there. Okay, so let's go to the destination real quick, and we'll come back to here again. So a few good points that you guys made earlier about the destination. Let me find my data flow here. Oh, I cloned that way too many times here. All right, first thing we noticed that the fast load was turned off. Let's turn that on. Okay, now if you have full control of the table, then table lock makes a lot of sense. We can save make this thing a lot faster by turning on table lock if we have full control of our system. But the other setting that's really important here is this max insert commit size. So let's imagine an example here where we're inserting 10 million records, or let's say 100 million records into a table. So I'm inserting 100 million records from DB2 into SQL Server in this example. With the default settings set right now, you see it right now. What's going to happen is my SQL Server is going to look all happy, and I'm inserting 100 million records. I'm inserting 50, 100 million records into my SQL Server. Why is it happy right now? Why is it at 2% utilization? Well, that's one of the big gotchas in SSIS. What's going to happen is SQL Server is going to be all happy-go-lucky until that 100 millionth record goes through, and then it will be taken to its knees. And the reason why is because it's max insert commit size. What this is showing us is how often should I do a commit statement. So it's going to be how happy-go-lucky, and the very last second, it's going to issue one big fat commit statement versus lots of little commit statements, and it's going to take your server down to its knees. So instead of doing that, if you have millions and millions of rows, change that setting to somewhere around 100,000. Try different numbers, 80,000, 120,000. Somewhere between 80 to 120,000 might be the right answer, depending on how wide the table is. If you change that, you'll see your SQL Server blip, and as it commits 100,000 records, then it comes back down. Then blip again, and then down again. Blip again, down again. So it's going to make it much, much faster because it's doing all those in one foul swoop versus all at once. Now, every pro has a con, right? Now, the con in this case is if we were to commit all that data, if we were to fail on row 90 million, then 90 million rows will be committed and 10 million rows are in some weird state right now. This is where transactions come into play and all those kind of things that are covered in our master's SSIS class that Devin mentioned earlier. So, but by default, it's all one big fat transaction. So you want to adjust that if you have lots and lots and lots of rows. You know, for most of your tables, leave it as is. Don't worry about it. You know, but for big tables, it makes a lot of sense to adjust. Okay. All right. So let's jump into our last topic for today, and that's all around parallel design. Now, Microsoft has made this a lot easier in the next version of SQL Server. As we say in our industry, right, tech industry, the next version will be great, right? So the next version of SQL Server, which they're doing a very, very quick build cycle, is going to have scale out built into it. But until then, it's not possible. So let's find a way to roll our own kind of system. What I want to do is imagine, for example, we have 10,000. It's actually a real example from a power company. We have a smart grid example, and I want to get 10,000 files loaded an hour into my database. Or you might have, let's say, for example, you might have 10 billion rows, which is literally an example we had recently. We had 10 billion rows to get from, actually it's closer to 200 billion rows, excuse me, 10 billion rows to get from here to a new database. Well, running one big fat select statement is not going to work. So luckily, the data in those 10 billion rows was partitioned. So I had, or 100 billion rows, excuse me. I had different chunks of data here. I had it partitioned by day. And each partition had about 10 million rows in each partition. This is a big bank in case you're curious. So each one had 10 million rows, and I would have like I had like different date ranges inside this. This might be Monday, Tuesday, Wednesday, Thursday. So wouldn't it be great if I could have a package that runs on 5 servers, each one taking a chunk of data from each of these partitions and bringing it over chunk by chunk by chunk? Well, that's what we can do with this whole pattern I might show you. It's called the work pile pattern. The work pile pattern will basically say, I create a table that shows me here's my queue of work I want you to tackle. It might be 10,000. It might be a row in here for every file that I have to process. The similar schema. It might be a row in here for every slice of that 10 billion row table I was talking about before, or 100 billion row table. Excuse me. In this case, what happens is I fire off 2 packages to run at the same time. Each one of those grabs a chunk of work. They process it, and then they say, all right, give me the next chunk of work, and so on, and so on, and so on, until all the work is at the very, very end, and there's no more work to be had. So this is a great way to kind of distribute the workload over that time. There was no way we could have loaded the file, those files, 10,000 files, or those 200 billion rows, without this work pile pattern. We tried, we had a weekend to do it, and we could not make it happen. So the only way we found was to do this. Now here, this is what our lab environment looked like earlier. If I have one process firing off for 8 files, it takes me 64 seconds to get through all these files. With 2 of them firing off in parallel, each process takes a little bit longer because I only have 2 cores here, or 4 cores, excuse me. But now we're down to 36 seconds versus 64. So we almost have linear growth in time now. If we do 4 processes, now we've reached diminishing returns, right? We have 28 seconds now. And we only get a 1 second saving by going to 8 because we've run out of cores now. So ideally what we want to do is we want to give each core of CPU would have its own unit of work to work on. Now this was a 2-core machine that ran this example, so that's why we're seeing it fall pretty fast here. So let me show you what this looks like real quick. I have this package here called worker.dtsx, and what is it going to do is it's going to go out to my higher ed database, and it's going to run a store procedure saying, give me some work. So that's all it's doing. It's going to go to this table called, it's called worker. I'm going to find it here. Oh, there's task queue here. All right, so I went and run this real quick. You can see what it looks like. Here's my task queue. In this case, each one of these is a file here. Okay, so I have a file for each one of these to process. So I now do the work right here. I actually process a file, and then I check the work back in. So essentially, it's a check-in, check-out process. I check the work out, I do the work, I check it back in again. So if I were to go ahead and fire this off, I want to run this on multiple cores here. So let's go ahead and really make this thing scream here. I'm going to drop over to DOS, and I'm going to go ahead and go out to my folder here, and let's go ahead and look at what the script looks like. And this is pretty well documented. I have this on my blog also, but let me go ahead and do a spawn worker.cmd, and this is what this looks like. You don't have to memorize this, just steal my code on my blog. Each one of these is going to kick off the package n number of times. I'm gonna go ahead and truncate the table, my queue table. Ignore all the stuff up top here, but basically I'm going to pass a number from 1 to a 20 or to whatever, and it's going to kick off the package that number of times. Okay? It's going to run it in silent mode to only show me errors. So if I do spawn worker 1, let me watch our task, our CPU here. There we go. All right, there we go. So we're firing off the package. You're seeing it run right here on this this little core down here. Oh, did it run? Nope, I don't think it actually did not run. Yeah, they're opening up and they're immediately closing. So it must be, I must have a wrong link in there. What's going to happen is we'd see each of those fire off, like you're seeing it. Look on the bottom right of my system tray there. You see, go boom, boom, and then it actually goes away. So if I were to open up spawn worker.cmd, here we go. What's wrong right now is we have this path here. It's pointing to 2008. I'll change it to 2012, and then just make sure. Let's make sure actually we have the right path here for this guy. That's a problem. All right, my guess is I got the problem all over the place, but let me just try. Let's try this one thing here and just see if we get lucky. If we don't, then we no worries at all. All right, so save that. Let's go ahead and fire it off one time. Oops, sorry, that's not what I want. There we go. Oh, it did something for a second. So it processed a file and went away immediately because it's still the package actually pointed to the wrong folder there also. That's okay. So what we can do here is a whole bunch of ways we can do this. Some of you guys are actually pointing out, can we use Service Broker? You could actually use Service Broker. You need some kind of queuing mechanism ultimately. So this right here is going to communicate with Service Broker, whatever your queuing mechanism is, MSMQ or whatever it might be, to say, give me some work. It does the work and it checks the work in or deletes it out of the queue. There's a whole bunch of ways of doing it. This is just showing you a few, kind of hopefully getting some ideas on how to do it. This is on my blog, and all the code examples all out there for that. But it's a great way to kind of scale out your SSIS package. All right, so let me go ahead and open up our last bit here. We have about 5 minutes left. It's been a long journey here. I know a lot of you guys have a lot of questions that you did not get answered. We had so many. We had over 600 on this webinar. So we had so many people on here. It was hard to get into all the questions. Barbara, we're definitely going to send you a discount code that's going to hopefully discount the elite training. So you should get that I think tomorrow morning sometime. We had a question from Kenny here. Should I use compression on tables that are accessed by SSRS and SSAS? That is even better idea, Kenny. So for a cube processing, your cube processing will go down immensely for processing cube. It's also going to increase your select performance immensely for SSRS. So those are two great examples, especially for fact tables and big transactional tables where there's a lot of replication of data. You're going to see a huge gain in performance. You will see a slight tick up in performance for CPU time. That's the only downside of that is the CPU time. Okay, let's see here. Is there a way to see how many buffers your SSIS package container can have? What's max buffers? Yeah, there are some counters out there. We have a product called VI Express, which will show you how many buffers are being consumed. It's actually tracked in event handlers, Kenneth, also. You can find it there. There's a whole bunch of operation stats that are out there. If I had more time, I can show you. But shoot me an email if you want to learn more about that. A whole bunch of questions about Task Factory. Yeah, again, send us an email. My email address is on here. If you like a demo of Task Factory, actually you can download it. There's no trial. It's actually all free. So just go ahead and download the trial, and it works in Visual Studio perpetually for free. It's only when you want to go to a server and run it outside of Visual Studio does it actually require a license. And a lot of the components are actually free in Task Factory. All right, Devin, do you have anything else you want to share before I wrap up my last bit here? All right, I guess that's a negative. All right, cool. Well, guys, thank you so much. We are going to be sending a discount code tomorrow for the on-demand training. So if you have any questions there, please feel free to reach out to us. You're going to get a special code for you guys. And so stay tuned tomorrow morning for that. And thank you so much for attending this webinar. I really appreciate it. I hope you found this interesting, and we'll be doing a lot more of these as time goes on. Thanks a lot, and have a great day.